Well, greetings. How you doing? We're here for a debate. Unfortunately, the guy that I had scheduled is said that he can't be here till about 9:30. It's 8 o'clock now. So thought we'd do some other stuff. I invited a couple others, but nobody was available. Unless maybe Flat Earth Aussie Jesus got back to me. No, not yet. But yes, aggressive typing. Oh, and a loop. I'm hearing a looping audio. I don't know if it's just me. That's not going to work well. I'm hearing myself, but very delayed. Yeah, I have a Elon Musk. I have a very loud keyboard, but I like it. So I replaced it one time with a different one, but all the keytops were missing. So, but I'm going to try to get this audio not looping. But that's going to be tough. Let me see. All right. Can you hear me? Looks like you can. The sound indicators say, yeah, audio's good. But I was hearing myself, which was just no fun because I'm going to confuse myself on the third or fourth time around. So, if any flat earthers show up, they're welcome to join. And in the meantime, I'm going to look at some videos. I got a really good one. Well, I say good. It's from Russian Vids, so it's not good. Anyway, we're going to look at that. If you guys have any others that you've seen lately and you want to surprise me, maybe we can do that. And I'm going to message one more time Mr. Ron Sheckelson. You hear that typing? Hey, Sean Hawkins, Surf, Kitsune Cavalier, Elon Musk, Logical Troglodyte, Amy Hogan, Stringer News 1. Let me see. We got Area 85 Restoration. Is that like your business? Hi, Harry. Been talking to you today. Clifford Reynolds uses ad block. So, all right. We want to look at this this goofy Russian Vids video. Does Right the Hand have a channel? Vic Tunes Entertainment? Oh, there's no way he could have a channel. It's going to be... He's going to interrupt himself. Oh, look. Hold on. Looking for his channel. Oh, there's... I don't see it. So the Hulk with the butt cheeks on his head isn't here. That's right. Ron Sheckelson was in the chat last week saying, I'll take you on after after Lemonbird. And I'm like, okay, well, let's go. And he's not here. So I think he had some schedule conflict. So it's sounding like an episode of the Waltons. I'm not. 33 UC. Does he actually have videos other than just saying, look, there's a 33? I'm still hearing myself. Crazy. That should not happen. Check, check. Check. Maybe that'll do it. Made some changes. So yeah, make sure you can hear me, please. So yeah, UFC fake sports style 2 Earth is more than flat 7 minutes from Right the Hand. Can that possibly be any good? Quantum mechanics atoms are fake. He does that on a computer, which requires quantum physics to work. So, man, that sounds like a great mess. So, all right. I'll get it there. Who suggested that? I'm coming after you. Haven't your parents... How do you say your Allison? I don't know. Haven't your parents taught you not to pick on the mentally disabled? Yes, my mom did. And that's why I don't use words that end in tard. So I don't know. We'll I'll be nice, sort of, maybe. All right, downloading. Write the hand and his quantum physics incorrect idea. Where did it go? Downloads.
Right the hand here. We're going to talk about the flat Earth and the other side of the coin.
All right,
As
here
you
it
see here,
comes.
we have the solar system, right? Right the hand here. We're going to talk about the flat Earth and the other side of the coin.
I'm not hearing any audio on it.
Here we have the solar system, right? You know, very unique looking
That's why.
object here. Okay. And then you have this very unique looking object, which is an atom.
Oh, but you're hearing audio.
Now,
but I'm not. Oh no.
The atom and the basis of the solar system are the same.
Yeah, wish we get a flurf into debate. So he said he's
in the middle with other things orbiting.
Oh, sent his.
Okay. This is how you know.
Yes, I found Goofball's channel. So yeah, or you know what, you're hearing it, but I'm not. So back to this.
Right the hand here. We're going to talk about the flat Earth and the other side of the coin. As you see here, we have the
I hear it now.
system.
Okay.
You know, very unique looking object here. Okay. And then you have this very unique looking object, which is an atom, apparently. Now, the basis of the atom and the basis of the solar system are the same principle. It is a large something in the middle with other things orbiting around it, okay? This is how you know they are both bullshit.
My goodness.
And then we get our first look at actual atoms.
Which crashed as I was firing it up for the debate. The OBS crashed. And
then you have this very unique looking object.
Oh my goodness.
An atom, apparently. Now, the
I hear his echo. Oh. All right, so OBS crashed, and then they had an update. So
a large something in the middle with other things orbiting around it. Okay.
All right, so he's talking about.
This is how you know they are both bullshit.
Oh, watch your mouth there.
First look at actual atoms. Which
Don't know how I'm going to have this resolved to watch the audio, or to get the audio for myself, because of the looping. Yes, the joys of live streaming. Logical troglodyte. So. It's too low because it's off. So let me see here.
About the flat Earth and the other side of the coin. As you see here, we have the solar system, right? You know, very unique looking object here. Okay. And then you have this very unique looking object, which is an atom, apparently. Now, is similar to a date scientific will change strontium atom.
No, I don't hear any of the audio. Yeah, Ron is a no-show. He's not a no-show. He didn't answer. Monday I messaged him, and Tuesday today, and he didn't answer till late in the day, and said he can't be here till 9:30. So I thought I would still do a stream here.
will change.
Are you hearing it? I don't hear any of the audio. Yeah, Ron is a no-show. He's not a no-show. He didn't answer. Wrong the hand. Yes, he's Monday.
Right the hand here. We're going to talk about the flat Earth and the other side of the coin. As you see here, we have the
so I can hear it now.
solar system, right?
I think you can
very unique looking object here. Okay. And then you have this very unique looking object, which is an atom, apparently. Now, the basis of the atom and the basis of the solar system are the same principle. It is a large something in the middle with other things orbiting around it, okay? This is how you know they are both bullshit. And then we get our first look at actual atoms, which look like balls. It looks like Braille. This is the achievement of man for the 1984 taking a picture of this. They moved them, they said. They arranged them to spell IBM, and there just happened to be one off in the distance there. Does that look anything like a nucleus with electrons moving around it? No, it doesn't. And why doesn't it? Because it's not.
Actually, it's because you're not zoomed in.
Bullshit.
Yeah, somebody when Right the Hand first got on the Discord server asked him what he had studied, and he said he had a degree in physics. So I don't know if that's so true, but it doesn't matter. He can be wrong either way.
Does that look anything like
beware clickbait from Shills? Yes, that is Right the Hand's.
And why doesn't it? Because it's not.
Yeah, he says he was messing with us and he's a baller. He's not. He was double Inception messing with us. So let's see what he says now. So yeah, so he's saying that because in this previous image that he didn't see the orbits of the electrons that that it doesn't, that it's not true. But of course that just shows he doesn't really understand how it works, because that's not how it works. The you know, I don't know, maybe he'll watch this, right? Maybe he comments on all my my posts on Facebook, every one of them. Of course it's off topic, but so yeah, because it doesn't look like this, which is just an idea, and it looks like this, which is also not, you know, it's not a picture of it, then he doesn't think it's real. Whatever.
Is the achievement of man for the 1984 taking a picture of this. They moved them, they said. They arranged them to spell IBM, and there just happened to be one off in the distance there. Does that look anything like a nucleus with electrons moving around it? No, it doesn't. And why doesn't it? Because it's not. And this all ties into quantum mechanics, because if you do a Google search, which I did here for quantum mechanics, you get shit that is very similar to the atom, because it's based on subatomic particles. And if atoms are fake, then subatoms are fake as well. They moved them, they said.
Wrong guy. But
right the hand here, we're going to talk. Okay, and how did they discover anything like
he just so he's incorrectly assumed that atoms are fake, and then he doesn't.
You get shit that is very similar to the atom particles, because it's based on subatomic particles. And if atoms are fake, then subatoms are fake as well. Okay, and how did they discover these electrons and atoms? Well, look at this. This is it. They took a beam of light or a laser or whatever, and they shot it at this special material, and they got this. This is the actual experimental data. This fucking picture here of, I don't know. What do you? They look. You get shit that is very similar to the atom.
So he doesn't understand what this experiment was. He probably didn't read any of it. He just looks at the image and says, "Nah, I don't think it's true."
Okay, and how
that's
did
it.
They discover these electrons and atoms?
Yeah, he does have a potty mouth.
Look at this. This is it.
Don't like that.
Beam of light. Look at that, and they say, "Oh yeah, atoms and electrons." I can look at that, and it looks like a. This is the. I don't know. Looks.
He doesn't understand.
Experimental.
Pretty clear. All right, hold on. Let's see if he has anything else.
Created a laser light. They're telling me a tree showed us this. Now,
what is this?
Okay, so this is what they did. I guess the people were getting a little restless, you know, the technology was progressing and nobody was seeing these atoms any better. So they said, look, we took a picture of a strontium atom, all right? And they showed us this.
So I have an echo. Yeah, see, I was worried about that.
Look at that. And they say, oh yeah, atoms and electrons.
See, I can hear myself echoing.
And it looks like a... I don't know. Looks like...
He doesn't understand. Pretty clear. I don't know how to do the... Like it worked. Oh, my watch page. What is this?
Okay, so this...
Oh my goodness. Sean Hawkins, you get the award. That was it. Oh.
Now, this apparatus here, you can clearly see the wires and the screws. Like, this is not a microscopic apparatus, okay? So, like, the tips of these things are probably as big as, I would say, like, a mechanical pencil lead. Those 2 points with the space in between it there, okay? That's what's housing the strontium atom, okay? These 2 graphite large pieces of metal are creating some sort of electromagnetic housing or whatever it's doing, some bullshit they're telling you. And let's see, can we get a look? Can we zoom in a little bit and see this strontium atom? Holy moly, there it is. Can you believe it? This thing, which is supposed to be the smallest particle in the world, it looks like it's about the size of a grain of sand.
Yeah. Yeah. It is the flux capacitor. And, right? I don't think it's an actual picture of the atom there, right the hand. So, all right, yeah. Sean said, check my Discord page. So I see Harry put something on my server in the general tab. And Sean, did you mean somewhere else? There's graphite on the roof. Oh, so computers rely on quantum tunneling to work. And if it wasn't for that, then silicon-based computers would not work. So he's writing this on something that wouldn't work. So good job, right the hand. Totally missing everything. So
they want you to believe this. Oh, but that's just the light bouncing. Oh, just shove it up your ass, bro. It's horse shit. Nobody's buying this. Well, people are, but I am not.
Well, how does this computer work? So that's all I had on that one. But now we got 3 curious minds. Let me scale that a little better. Getting the hang of OBS slowly. Maybe not. What do you think?
Everyone, looks like I'm live. How you doing?
I'm doing great.
Park, Albury Court Estate, Bristol.
I love Bristol.
My Sunday morning walk with the dog, and a couple of thoughts to share with you. So it would be great to have a few join me. So just wait a few minutes to see if anyone.
So yeah.
Said that I'm live.
Jump to 5 minutes.
Yeah, I am. Yeah. You lived on a globe.
Oh my goodness.
What did you say?
He's talking to kids.
If you don't know the answer, that's fine. You don't know the answer. It's Robin. But if you look for the channel, just search for Flat Earth Bristol Meetup.
No. Don't. You don't need to talk to kids.
So lads, let's just do a basic science experiment, yeah? So you know how water...
Yes, Cliff Reynolds. I was on the Non Sequitur show with Right the Hand, and he kept insisting that he could fly like Superman, and if he could show me the super complicated math that he could fly like Superman, would I believe him? And Booleanator had enough because he just kept going on that. So, yeah, that was the guy, and he keeps going on about that. He kept going. Like he's posted on my Facebook. I don't know. He like left the UDSA server, but he still goes after me on Facebook. So if you want, you can go jump on my Facebook and see his nonsense continue there. So yeah, I'm sorry. I increased the volume there. I gotta remember.
In a pond or a lake is always flat. Yeah? And if we look out at sea, if we go down to the beach and we look at the ocean in front of us, it's always flat, isn't it?
Unless there's waves.
Yeah, unless there's waves. So we might see a little ripple, yeah?
Yeah.
But if
that's him.
If you that's me.
Wait,
That's me.
How many souls do you have? Oh,
2,000.
Hey,
Yeah.
Marvel girl.
Getting on for 2,000, yeah. There you go.
Just thought I'd make a quick video to sum up what
He's doing Inception on himself.
first of all the venue.
So I tell you what,
Hey, this
I
is
was
you right now.
that's and I was on.
So
There you go. That's my mate.
You're lying. He lied, guys.
With
You guys are lying.
Excellent. So let me ask you that question, yeah?
Yeah.
You know how the water's flat on the ocean, yeah?
Yeah.
And the Earth is supposed to be covered 70% of water.
Yeah.
So how does the water bend?
So I love when they say the Earth is covered with 70% of water, because David Emery did all the math on that. It's a little rough, of course, but it was he took all the land masses of the countries, the area, and added in Antarctica, and then did the math on all of the oceans, and came out to 70%. So if this guy's saying that 70% of the Earth is covered in ocean, that only works on the globe, because when you do the math for flat Earth, it's not 70% because it's so much distorted big in the southern hemisphere, so that everything's wrong. So the numbers are wrong. Right the Hand versus BM Furball, funniest right the hand video ever. Was that BM Furball's video on him? Yeah. The one about his BM's wife having that pregnancy problem, right? So, well, this guy, let's hear him a little more here.
I don't know.
It's a bit mad, isn't it?
Yeah.
So here's another one for you. Let's say
When's he going to offer him candy and say, hey, do you want to go for a ride in my van?
you're in an aeroplane, yeah?
Yeah.
And all your seats are upright, yeah?
Yeah.
You got a glass of water in your hand,
Yeah.
and you're going from, say, London on the top of the Earth, and we're going to Australia on the bottom of the Earth. What's happening to my
Wait, London's not on the top. It's the North Pole, Mount Meru.
glass of water? Do you think in real life it actually tips over though?
Oh, jeez. He doesn't understand relative anything, man. Yeah, like 33 UC had that same problem. He thinks that the model is that it's upside down. It's not upside down. There's no upside down in space. Down is towards the middle. And here he is, an adult, should be, well educated. He's talking to kids and telling them the dumbest basic thing.
Do you think that's mad?
Yeah.
You think that's a bit bonkers?
Do you like gladiator movies?
Have
Have you ever been in a Turkish prison?
So let me ask you another question. You know NASA sends rockets up to space,
Yes.
or that's what they tell you, yeah?
Yeah.
What if I said all those pictures of Earth from space were CGI? They're made up on a computer.
Every one of them were computer.
I wouldn't be surprised.
Well done. Did you hear the guys there? I wouldn't be surprised. Do you mind if I ask you why you came to that decision?
I don't know, just because
I doubt anyone's actually
Yeah,
been into the planet.
because like people say stuff, but most of the time it's probably fake.
High five. And
Yeah.
why did you say I doubt if anyone's actually been into space?
Because like if on the planet, because I don't know, they probably can't even live on the planet. I don't know.
They probably can't even live on the planet, but
So a kid has personal incredulity, just like a flat earther, is their main disproof. So, well, that's what you get. Yes, BM Furball interviews Mark Sargent. The enemy's gate is down.
can I just give you an idea of how crazy it is? Let's just say have you heard of the International
Clark.
Space Station?
Hey kids, you want to see the
Right,
moon
so
in my
apparently
van?
that's going 17,500 miles an hour around the Earth, okay?
Yeah.
And they've got cameras there, and they supposedly take a live feed of the Earth. But wouldn't it be amazing if they took a shot of Australia with the aeroplanes upside down? Because they'd have to be upside down, wouldn't they?
Yeah.
No.
Or if they zoomed in on the World Cup and got Ronaldo kicking a goal, a live event, and they showed the video from space, that would be pretty cool, wouldn't it?
Yeah, it would.
But
He thinks they can. Oh, yes.
it never happens.
Yeah, who is this guy? Darn it. All I did was 3 curious minds. 3 curious minds.
And why? Because your answers
No, that's
before.
Sorry.
I don't think.
Those kids are the curious minds. High Harry has he knows who it is.
I don't think we've ever been to space. Well, I'm impressed with you that you're willing to question it.
Yeah.
Aren't these guys cool? Aren't they absolutely cool that
Them two have a YouTube channel. Yeah.
that they're willing to be? They're willing to.
Yeah, what zoom lens exactly? But of course, there is some pretty decent camera work from space. Google Maps. Some of it is satellite, some of it is from planes, but most is, especially the early stuff. Told me he's gonna say something dumb. I don't know who he is. Just got the link from Radical's Discord. All right, so looks like the name of his channel is Lifted the Lid, and he's from Bristol. So yeah, can they zoom in on somebody being upside down? Oh my gosh, can you just put a little effort into understanding it before you think that it's fake?
They're willing to say that maybe that's a fake.
Yeah.
I'm impressed because when I was a kid your age, I just believed what my teachers told me. And then when I went home, okay, for instance, if I said, why don't we fall off the bottom if we're in Australia? And your teacher just says gravity, don't they?
Yeah. And then they also what's on the edge of the verse, and then they say, oh, it's just a cliff on the edge of the earth.
It's just a cliff.
That's
So
what everyone says.
yeah, that's right. So you're kind of told to laugh and mock at the idea of a flat Earth, aren't you?
Yeah.
Yeah.
You're being honest. How cool is that? So let's have a think. You're told that it's gravity holding the water upside down on the ball. And then you go home to your parents and they just tell you what they were taught at school.
Yeah.
It's not their fault. My parents told me.
Yeah, just because you're told something and you didn't question it doesn't mean it's wrong. It might mean it's right. Yeah. He runs Uncle Touchy's Secret Naked Puzzle Basement. Oh, jeez. If you've seen The In-Betweeners, it's a British show, so and this is not the time for British people to be awake normally. But the one guy's buddy, he lives in a van and gives him rides everywhere in his van. And all of his friends are like, "Don't do that! What are you doing?"
The same. But then when I got older, I thought, hold on a minute. If I'm in an aeroplane and I'm flying and I'm supposed to be upside down by the time I'm in Australia,
Yeah.
that's really crackers.
It's not.
And when you
still right
watch
side up.
a time-lapse footage of an aeroplane, you can see that horizon's completely flat all the way through.
Get where you're
So it
coming
doesn't dip at all. You guys are really cool. Thanks
If
for
I were
coming on my
these kids'
channel.
parents, I would be
All
calling
right,
the cops.
give me 5.
Yes.
Thank you.
from. Bye, guys.
Yes.
Cheers. Thanks. How cool was that?
Strange guy in the woods.
So didn't expect some wide awake boys to be interviewed there. I haven't concentrated on Ted at all, but he's got his ball. And did anyone comment there? These boys were wide awake, weren't they?
Okay.
Yeah. Dave.
So I was talking to somebody at work today, a lady, and she's like, no, the Earth couldn't be flat because if it were, all the guys in the world would go to the edge so that they could piss off the edge, just so that they could pee off the edge of the Earth. There'd be luxury trips bringing you to the edge so you could pee off of it. That was her idea, that the disproof of the flat Earth. I like. Well, wait. When does he bring out the ether-soaked rag? Yes. Yes, he'd give the dog a flat ball. Well, you know, they do have things for dogs. Hold on. Right, like this. Right there. Super secret project with those. Oh, Anthony Davis. It's 1:30 a.m. on Wednesday down here in Australia, and we're upside down. So, yeah, oh my God. A Marvel girl. She's right. Yes. I would totally. I would be like, I need to go to the edge so that I could. Yes. Vote if you would go pee off the edge. All right. Let's. Does he have anything else in here? Let's see.
That doesn't make any sense. And they're willing to actually say.
Tell everyone about
if no one's been to
debunking
space.
the AE
How
globe
cool
map.
was that? Hey Kerry, thanks for joining.
Effie News, how you doing? He's a little troll. I don't know if he's serious though. He's a little too silly to be serious. So on Friday night, I was the summer solstice, the northern summer solstice, and I used the AE map to predict where the sun would be according to the AE map. And FE News got on there and Edge P. FE News got on there and said that we don't even have a model, but an awful lot of them do have a model. So I think FE News, you're kind of in the minority at not having a model, but it doesn't matter. If you don't have a model, you have nothing. You're not serious, right? So if you were serious, you'd have a model, because how could you not say this is at least what it looks like? And the thing is, FE News, you're a little bit stuck because you don't get to pick where the land has certain coordinates. There is no edge, just an ice wall protected by killer penguin sentries. Yes, they have guns. They have had the same guns since the 50s, so they're getting a little old. DJ Torque 1010 would pee. Like everybody would. That right there, that's proof there's no edge, right? Flat Feet Pete did not fall off. So, you don't get to pick, FE News, where the coordinates are, right? There are longitude and latitudes, and they're accurate, and you can use your phone and or just a standalone GPS to find out what they are. And then whatever map you use, you have to put those coordinates in that spot. And there's certain things that you don't get to mess with for sure. Like the distance from latitude to latitude is always with a very slight modifications, 69 miles or 60 nautical miles. So you don't get to change that much, right? So the AE map keeps that even. The one thing the AE map doesn't do is it messes up the distance between the lines of longitude. That's why Australia is so much too wide. So anyway, FE News, if you are a real because you only said one thing in here, so I don't know, maybe you're Hold on, I gotta pour some water in here. Maybe you're a Poe. And I got some creaky blinder water here. All right.
And they're willing to actually say, I wouldn't be surprised if no one's been to space. How cool was that? Hey Kerry, thanks for joining. Yeah, it was.
They make a shiwi for women to pee off the edge too. I was gonna say that, but I decided not to. DJ Torque. Maybe you should have decided not to. But all right, fine. It's been said. Marvel Girl, there's your chance. 69 miles. 9 minus 6 equals 3. 3 times 10 plus 3 is 33. Coincidence? You're right. That is the kind of stuff that 33UC would like, except that math is too complex for him.
Good morning, Marilyn. I hope you managed to catch the last 5 minutes. But I just was chatting to a group of kids, they can't have been more than 10 years old, who were excited about the thought of going live on YouTube, and they just joined me just now and basically were willing to accept that the moon, no one's been to space, to have freedom down.
Right, just him rambling. So maybe we'll skip that. He's not in a car, so I don't quite know what to do with him, right? Because they're all in cars, always in cars. All right, I have another video. What? Hold on, I'm Marvel Girl. You're gonna pass on peeing off the edge, even with a chance now, right? There's technology has solved that problem, and you're still gonna pass. Oh my gosh, how can people be like that? All right, fine. So you remember that guy? I actually contacted that guy to see if he wanted to pop in, but he didn't respond. Telling small kids lies like that, he should be arrested. Yeah, that'd be good. So simple experiment. Let's see what.
What's up?
That destroys. I'm sure it does. I'm still getting the hang of this. Like how to do videos the right way in OBS. But here we go. And I like how the flat earthers are always like, oh my goodness, I messed it up. There we go. Let's go bigger. There we go. I like how they always say hi or hello YouTube, as if it's like they're gonna talk back. So, all right.
YouTube, that again.
I bet that's too loud.
Just taking a quick run to the store. Figured I'd go over a quick little experiment that I learned about the other day that absolutely destroys gravity.
I'm sure it does.
Thanks to Dave Murphy from England, flat earther Dave Murphy.
Yeah,
brought this.
That's allegedly Dave that drinks his wee.
To my attention when he was debating that particle physicist a couple weeks ago, and he absolutely destroyed that particle physicist in a debate. It wasn't even close.
Oh, I think I saw that debate.
So here's the experiment. Go to Walmart, get you one of those tanks of helium that fills up birthday balloons.
Yes.
We've all seen them. They've sold them for a couple years now. If you don't understand what I'm talking about, go to Walmart and look for it. It's a tank full of helium. Compressed helium. So go get you a tank of helium. Weigh it when you get home. Shake it. You'll feel there's a liquid inside.
All right. Right there. He thinks that you can buy a tank with liquid helium inside. He doesn't know anything about what he's talking about, because you can have liquid helium at somewhere around 1 Kelvin. Anthony Davis. Is this a debate, or are you making fun of mentally handicapped? I'm not trying to make fun of mentally handicapped people. I invited that guy. He didn't respond. I'll be pointing out the wrong. Sean Hawkins loves this. You love this guy, Sean, or do you love that guy?
Weigh it. See what it weighs. There's compressed helium. Compressed helium is just helium that is more dense. They've compressed it to a higher density level. It becomes a liquid when it's compressed to a certain point. A lot of gases do this, like propane. Or
Helium does, but not in the tank you're going to buy at the party store.
hydrogen, helium, they turn into a liquid when they're compressed. All you're doing is increasing the density of the gas. So, when it's in the tank, it weighs 10 pounds. You set it on a scale. Maybe with the metal tank, it weighs 15 pounds. Set it on the scale. Now take that same exact helium that's in the tank.
All right. Yeah, there's so much wrong to point out. I know where he's going with this. I've watched. I only watched up to where he said the liquid ahead of time. So, this guy dips. So, here's where he's gonna go. He's gonna talk about weighing it, and it has a certain weight or mass, really, and then you fill some balloons, and the weight of it will go down. Yes, it will, and then he's gonna say that the weight went down. So where did that mass go? Because all the balloons are going up, right? He doesn't understand. He doesn't understand buoyancy and how it works. But let's see where he goes with this.
Tank and put it in a gigantic balloon or many small balloons. Once you've emptied the tank, weigh the tank again. It should weigh 10 pounds less, or however much helium was in the tank. So weigh it first, empty it, weigh it again. It should weigh around 10 pounds less. So now this proves you've taken 10 pounds of helium out of that tank and moved it to the balloon. All that you've done is made that balloon, or made that helium have room to expand and become less dense. It was compressed in the tank. You empty the tank into a balloon. That exact same 10 pounds of helium will now float away from you when you let go of the balloon. The exact same 10 pounds. Gravity cannot explain this in the least bit.
Oh, but it does. And I did a video already on buoyancy. All right, so quickie, why am I so small? Because this was my video for myself and my guest while reviewing something on the screen. So I don't have to be big. Am I really worth looking at like that much? Come on. I'm not that pretty. Let's spend more time looking at that guy. He's way more. I'm not kidding. No, he's not.
Sorry, I'm backing up to the job, but gravity cannot even begin to explain this phenomenon.
Okay, buoyancy. Should we go over a little calculation with buoyancy? Is that worth doing? Is that interesting enough? Let me know. I will pull up a web browser. Gotta make me a new VLC or OBS thing. I'm gonna do let's see. AB Science isn't here, but I saw that Marvel girl. Somebody said you said I'm breathless. Is that me? No. Python. So AB Science would be very excited for my Python. Oh, this isn't a... Oh, this is the one, yep. It's side by side. I wanted top and bottom, but that's fine. So, here we go. I'm going to switch this up. Going to add in my web browser. Window capture. And I'm going to do... There it is. You don't see it yet, but I do. Got to make it wider. How many of you have programmed in Python? I do pretty often. But here's the hint. If you're ever going to program in Python, it's just about going to Stack Overflow. Or just Google whatever you want to do. You just Google it, and then whatever Stack Overflow has is the best. That's the correct the correct answer. That is the easiest way to do. There we go. That's how you do Python programming. So here's what we're going to do. We're going to pull up the formula for buoyancy. Who's got that handy? Anybody have that memorized? I have it in Evernote. What's Python besides a snake? Python is a programming language named after Monty Python. Did you know that? In their documentation, they encourage using examples that include Monty Python references. So, all right, I have, right here it is. We've got, well, I guess I knew this. We've got the force equals, it's rho times G times V, right? So we've got rho, which I'm just doing a P, which is the density of the fluid. Right? And we've got G, which is I don't think I've ever programmed live in front of 49 people before. 9.81 is close enough. And then we've got V equals, that's the volume displaced. Right? All right. Fantarang. No, Ron Sheckelson did not chicken out. He said he can't come until 9:30. So doing some other stuff until then, and maybe he'll show up. I'm hoping. I think he's pretty active on the 24/7 Flat Earth Discord server, like Lemonbird is. So, all right, density of the fluid. Oh, my goodness. These are comments. So there's the program. Density of the fluid, though. We need to find the density of the fluid, which would be air. Anybody? Don't fail bus now. All right, density. Well, I can do that in this here. Here we go. You'll see this, right? Density of air, and we want it in SI units, so that's we'll just take this 1.225 kilograms per meter cubed, right? And then the volume displaced, right? So we need an average balloon. And Clifford Reynolds, did I take math or physics in college? I did. I studied electrical engineering and computer science, and I've been a computer scientist. I've not Since college, I haven't done electrical engineering. So, volume of a balloon, Department of Physics, University of Illinois. Come on, give me the answer. I don't want to do the work. DJ Torque, Lemon Bird is your favorite flat earther? Why is that? I mean, he's actually kind of nice to talk to. My goodness, people, make it easy on me. I have a least hated flat earthers more than liked. Is a list. Yeah, NA, I can't stand Lemon Bird. That's ooh, balloon volume. Oh my goodness, you're not giving me the answer that I just want. There we go. Content. 24 liters, 15 liters. So, you're not seeing that though, are you? I'm in the wrong tab, wrong browser. So, we got 15 liters for a balloon, we'll say, right? And we need that in meters cubed, right? So, there we go, back to here. Our volume equals that. So what do we think? We got our density of the air is 1.225. Gravity, volume. Let's run it, see what we get. System air. I didn't put a multiply in there. Syntax error. There you go. That's the force. 0.18. That's going to be newtons. Right? I'll put that in here. That's the buoyant force. Now, the question is, how much does the balloon plus the helium inside the balloon weigh? Right? So we need the density of helium. Helium 0.179. Are you still with me here? Oh my goodness, I spelled that terrible. Helium density. Lemon Bird is into numbers too. He thinks there are suspiciously many 6. Yeah, he's one that takes the anytime that there's any manipulation of numbers you can do to get 3 6s in a row, he does it as proof of something, I guess. So, all right, helium density, and then the volume is 0.015 cubic meters. So we need to do, it's going to be helium mass equals, so the volume displaced is in meters cubed, right? And the helium density is in kilograms per meters cubed, and we want to get rid of meters cubed, so we're going to take the density divided by the volume and then print that. Helium mass. See how that goes. 11. Crap. I did it wrong. Oh no, that's kilograms, and the other is in newtons. All right. What am I missing? Thanks, Quickie. I appreciate the info. Oh, what did Quickie say? Very smart guy named Dykstra wrote a paper about it. Google Dykstra. Go to Dykstra. Go to considered harmful. Oh. Yes. Yeah, don't you need the temp of helium to... Yeah, you need the ideal gas law to do it correctly. With world. But we're not trying to be super accurate here. We just want to see if the force if the force of the buoyant force would be enough to lift the balloon. So I did this before, I promise. And I'm missing it all. I have it in my notes, but I'm not going to find it on the fly here. So darn it. I don't want to spend too much time on this. I'm gonna just flop around for a while. So let's stick with how we can calculate the force, right? Which requires gravity. So that's going to be the force pushing up on the balloon from the air coming around it. And that's the key that they miss, because they think that there's something going wrong when things go up because they're lighter than air. But the air is denser, so it's down here and it says, well, I want to be here, so helium balloon, you need to go up here because I get dibs on being down here. So it pushes it up. And the gravity is important because the gravity is pulling that air down into its place underneath. So Saka is a high-quality signaler like Immutable Destiny. They often choose not to speak when they could allow time for additional noisy information. Did I miss something there? Or are you just pasting goofiness? So, all right, we were watching... I'm going to go back to that then. This goofball.
And that's what science is. The study of a natural phenomenon. Observe a natural phenomenon, which is dropping the tank of helium or setting it on the scale. You drop it, it falls. You move that helium to a balloon, you drop the balloon, and it rises. The exact same 10 pounds of helium, just put in a different container.
And much, much larger. And that's the key that he's missing, of course. So, all right. Oh, do we want to review?
Because yesterday's video went down such a storming success, the ballers just don't accept the fact that the way it happened is the way I said it is. So I thought I'd do a little bit of research to see if there was other examples of where change in the density or the volume of an object can influence its position, and will it force displacements by changing things.
And I looked at this with Mike
relative to
Bertelson.
mass and or not relative to gravity. And what do you know? This next clip I'm going to show you is two segments from a video of a teacher teaching teachers how to teach children the science. So it's aimed at the adults, it's not aimed at the children. But let's just see how it's
that's key. It's aimed at adults, not at children. So he's not, this instructor, this lady, is not instructing kids, and so he's not, or she's not going over all the details like buoyancy. So, somebody's saying, yeah, in his car. So that guy is always in his car. And in Minnesota, they recently passed a law on August 1st, it goes into effect, that you cannot flurf and drive. You cannot drive while recording yourself on video. Specifically calls that out, that it's against the law to drive in Minnesota while recording yourself on video. So bad news for Minnesota flurfs.
Destroys the idea of gravity for you fucking idiots.
Hey,
there is no such thing
watch
as
your
gravity. And this proves that there is such a thing called relative density, and it does cause displacement. F equals ma. If we have a mass that accelerates, it means that there's got to be a force. Sorry guys, if Newton's first law of motion is a thing, then it has to apply here, and it means relative density is a force after all. Read it and weep, dickheads.
He just gets everything wrong. Like, I've had some conversations with Sleeping Warrior, and they're usually pretty good, but come on, it's just wrong, man. Yeah, what about dash cams? I think dash cams are
One of my
fine.
students' most common questions is, are you going to blow something up today? Well, when we get to gas laws, I tell them, we're going to blow something up today. And then I do this.
Oh my
That only
gosh.
works once or twice throughout the year.
That
'cause
was
then
never
they start
funny.
Getting a little angry at me. We're going to start with seeing how temperature affects volume. So we've got a Mylar balloon up front. When I went to the store to buy the balloon, I asked for them not to fill it all the way because I want some room for expansion. And as I was checking out, the woman said, well, they can fill that up for you. I said, no, this is the way I want it. And in fact, I may let some more air out or some more helium out. But it is filled with helium. And at the bottom, I have paper clips, and it's trial and error. How many paper clips do you need to get the balloon to stay down, but be able to rise as well? And I can leave this up for a few days, but even a Mylar balloon over time loses.
Yeah, Unirock 2, Sheckelson? He's supposed to be here in about half an hour, so we'll see. We'll see if he makes it. He, last minute today, asked if we could move it to 9:30, so.
Some helium, so the second day I may have to take off one of the paper clips, or I've even cut paper clips in half.
So, in this horrible color font, notice she doesn't say wait as the rumpus would want you to believe is the correct phrase.
Just to get the right mass to hold the balloon down. Okay, this is set up for them, and if you have a hot light bulb, a heat lamp, you won't even have to touch it. You just have it set up in a corner of the room, and if the conditions are right, if the humidity's good, then it'll work all day long. If it doesn't, you can help it along.
I
This
love
is
her
just a heat
safety
gun. It's a paint
glasses.
stripping gun. Okay, it's like a hairdryer, except it doesn't blow as much air, and it gets hotter. And so what I'm going to do is heat the balloon. Now, what I don't tell the kids this because it's going up and down several times, but what I want them to focus on and what the questions lead them to without being too blatant is what they're looking for is that the volume is going to increase. So right here, I've got a section of balloon that I've intentionally collapsed a little extra. So we're going to look at that section of the balloon as I heat it.
Wait, B-Ball for life, you can imitate Sleeping Warrior perfectly, like his voice? We got to get you some on recording here.
And we should be able to see that as I heat the balloon, the air inside is going to increase in temperature, and that collapsed section of the balloon is going to fill. And as it fills, and of course we don't tell the kids this right away either, sometimes you have to help it a little bit. As that fills, we've increased the volume without increasing the mass, and therefore the density should decrease.
Therefore, the density should decrease, she says. She does not say that there was a force of buoyancy.
Yes, because she's speaking to adults. She doesn't need to. She's not actually just speaking to adults. She's speaking to adult science teachers. They don't need to be told it's buoyancy, Riley.
If the masses remain the same, even little g is a constant as gravity is meant to be inversely proportionate to the mass of the object, right? No mass was lost, but it moves.
Because it got larger. And when she warmed it up, it got larger. Right? Relative density is a force. So, unfortunately, it's not. And the dimensional analysis is the first step that you can do. And so if you haven't done dimensional analysis, that's not too difficult to do. I like it because you don't mess with numbers. You just take the stuff, right? Like the units. So density is volume over area, or mass over area. So it's kilograms per meter cubed. Kilograms per meter cubed. Relative density, I don't know. It's like subtracting one from the other, which would give you 0 units. But then, so I don't know what he thinks would actually be units from that. But force is kilogram meters per second squared. Completely different dimensional analysis. Not even in the same neighborhood. So, Sleeping Warrior is taking this as proof of something. Yeah, holy crap, the stupidity. So, it doesn't make sense. And he just has such a strong like preconceived everything has to go this way, and so he knows that if gravity was a force, then it would collapse the Earth into a ball. So you know, just a priori, it's not a force.
Equals ma. Relative density is a force.
Oh, Gary. You had to copy paste that in there. Horizons are just optical limits of angular resolution determined by the elevation of the observer. No boat has ever sailed over curvature. That's wrong. You know, give us the formula, Gary. Give us the formula to calculate and predict how they will be, you know, obscured bottom up, right? That's all you need. Once you post that, come back when you have it, and but don't come back if you don't have it, because what you said doesn't make sense.
And it should rise on its own.
Oh, Chris
Then it's going to stay
Berry.
at the top, and the kids will walk away and say, "Get back there, you're not done." And if we continue to watch the balloon, we should see now that as the balloon cools, it's also shrinking. Now again, they're supposed to discover these things for themselves. As it shrinks, the volume changes without the mass changing, and therefore the density decreases.
So yes, and as we looked at earlier, when we had our, let's go here, we had the formula there for the force of the buoyant force. I can't see it. I gotta get my browser up. There it is. The buoyant force equals the density of the fluid times gravity times the volume displaced. So when the volume changes, then that changes the entire formula. And so when you have something right on the edge of floating or not floating, then when you increase the volume, but you keep everything else the same, the buoyant force is stronger. So here it is again. He's getting all confused. So so Gary Weinbenga says angle of view, surface terrain, and angular size are all the primary reasons for obstruction of bottoms. No, Gary, they are not. Bring your formula, then we'll test. I have a formula. We'll test observations. You bring yours. We'll test observations, and whoever's closer wins and buys the other Starbucks. So all right, Chris Berry. I was trying to get a hold of you earlier. But I don't have any way to contact you. I was going to write something on one of your videos, but I didn't. So, Chris, would you like to join? Just an observer. Well, would you like to be on a future one? Because you're on my list of people that should come on a Tuesday here sometime. Send me an email, mctoon@mctoon.net. So I'll write that here. So the reason why today is because Ron Sheckelson is late, and I don't know if he will be joining at all. I hope he is, but so I had thought I'll see if somebody else wants to come in his place. So Gary, the geometry of perspective is your imaginary curve. Yes, you've said that before. Could you stop copy pasting and actually engage in a conversation? You know, like. Explain how that works. Let's see the formula for that. So you don't have the formula for that because it's just nonsense. And you think it makes sense, but it doesn't. It really doesn't. People that have looked at this and know what you're talking about because they work with these kinds of things, right? We're like, no, that doesn't make sense. The angular perspective is just nonsense. So Clifford Reynolds said that discussion he had with Flat Earth, he said it every 30 seconds or something. I don't know for sure who he's talking about, but all right, let's finish this here.
The volume changes without the mass changing, and therefore the density decreases. The volume changes without the mass changing, and therefore the density decreases. What I have in here is a ketchup packet and an eyedropper. Now, this one is very difficult for the kids to get, and it's my favorite because even when they think they have it figured out, I'll come and ask them a question and try and confuse them because they don't have it figured out. So I'll show you what happens, and then we'll try to figure this out together. Another fizz keeper, it's full of water. The eyedropper is mostly full of air. The ketchup packet is the way it came from the store. And you got to play around for ketchup packets because some of them don't float. But this one does. And I make sure it's screwed on tight. And I pump the bottle, and what I want them to see is what's happening inside the eyedropper. And if they can see it, what's happening to the ketchup packet. That's not always so visible. So let's focus on the eyedropper first. Yeah, the ketchup packet wants to be in the way. The eyedropper is filling with water. Does that mean the air is...
Oh, yeah. Clifford Reynolds. Yeah, you're talking about Sleeping Warrior saying snap the 1 and 2 constantly, of course. He completely missed the concept of what he was talking about. Which wasn't that it ruined Newtonian physics, Newtonian understanding of gravity. It changed the mechanism by which it worked. In the Newtonian system, they didn't really have a good idea. It was kind of something left to be figured out later. It was spooky action at a distance. And in Einstein, it's about the warping of space-time caused by mass in that area. So that the mechanism by which it worked is what they're talking about. So, Gun Tank 214 says you should check out U.S. Army FM 6 and then a bunch of numbers there. I will look those up right now, and then we may get to that. But maybe Chris Berry's going to join us. Come on, Chris. And I've invited Gary Wybenga, and he said maybe sometime in the future. So, what? MC Tunes, no, not Flat Earth Aussie Jesus. I actually did invite him, yes, but he didn't respond to my email. So, Marine Artillery Survey Operations. So, all right, we'll look at that. Riley, yeah, all right. So we were saying Riley didn't understand what snap the wand in 2 meant. So yeah, all right. So let's keep on this here. This is a great demonstration. It's a little nuanced, but the key is to look at that the ketchup packet is sealed and that eyedropper is not.
It's coming out of the eyedropper. Well, no, if the air were coming out of the eyedropper, we'd see bubbles, and we don't see bubbles. So what's happening to the air inside the eyedropper? It's being compressed. All the air that was in there to begin with is still in there because we didn't see any bubbles, but it's taking up less volume. Okay, so we're doing a pressure-volume relationship. Also, since the eyedropper's filling with water, the eyedropper's becoming heavier and therefore more dense. So we should be able to get that eyedropper to sink all the way to the bottom.
But wait, the rumpus tells everybody that weight is a force, density is not a force. So how is this getting to the bottom if gravity is doing it?
Because the buoyant force is being reduced. That's why. Why not 100%? Chris Berry, Marvel Girl, the rumpus says it doesn't always. All right, hold on a second. I need this context here. What about when the curve calculator doesn't match reality? Yeah, that's a good point. It doesn't always match, and part of the point is that refraction there's a guess at what they call standard refraction, which is under conditions that are what they call normal or non-chaotic, and then sometimes it doesn't match. And of course, the thing about the curve calculators is that if you look at it and you say, oh, well, we can see too far. It's not too far. Therefore, it's flat. It's too far. And a better conclusion would be, well, the radius is larger. So yeah, Riley knows the answer to that, but it is a play for his followers. They need a daily dose of BS. Yes. All right, Chris, it'll be more fun if you're in here, buddy.
Something's changing inside, isn't it, boys and girls? And the rumpus would have you believe that it was gravity that was doing it.
Yes.
But it's clearly not. By putting the pressure in, it compresses the gas inside the teat pipette, and that forces the density to change, which then in turn makes it displace, just like the salt water in the egg. Where is the gravity?
It's part of the buoyancy. And well, the first time I watched this, I missed that she has a little pumper thing that she's pumping on the top of it to increase the pressure inside the container there. So Chris is saying you can't join. That's fine. Let's set up another time. I think it'd be good.
Gravity, if it was there at all, was a constant and it didn't cause shit, did it?
Well, now wait a minute.
He is condescending.
The ketchup packet is also sinking. Why would the ketchup packet sink? I'm not pumping water into the ketchup packet, so I'm not increasing the mass of the ketchup packet. I must be changing the other thing that affects density, which would be volume. And most of the kids, and you might need to pull some teeth on this one, will remember that there is a little bit of air inside the ketchup packet. And as you pump on the bottle, you're increasing the pressure, which will be compressing that air, causing the ketchup packet to take up less volume. The eyedropper is more mass, that's why it's sinking. The ketchup packet is less volume, but the same mass, and that's why it's sinking.
So it's changed the volume, which has changed the density and the medium.
Oh, darn it, I clicked the wrong button.
Because yesterday's the medium which it's in, then...
All right. I meant to pause that instead of jump to the next video. Let's see it again.
And the medium which it's in then changes its relative density to the new.
It changed the buoyancy calculation. The buoyancy is what it changed. So the buoyancy force went down when there was less air by volume in there. So yeah, and a sleeping warrior is a walking Dunning-Kruger. That's an interesting thing. Hold on a second. Let me see if I can. So here's the Urban Dictionary. So I wonder if we could look up any words on the Urban Dictionary here that might apply to flat Earth, like Riley, the Riley-Nodell effect, for example. What is going on with that? There it is. The Riley-Nodell effect, synonym for the Dunning-Kruger effect. That guy, who we just saw, is such an ignorant and arrogant flat earther, he suffers from severe Riley-Nodell effect, even worse than Pratt does. So there you go. Urban Dictionary has the Riley-Nodell effect. Feel free to use it.
Density caused by the volume change, and there's a displacement, and it's the change in the density that's doing it. It's got nothing to do with gravity, has it?
It has to do with buoyancy.
Rumpus is misleading people by telling everybody that it's to do with weight, because weight's a force. Let's listen to her next 2 or 3 sentences.
Oh my goodness.
She's referencing the children, but let's change it in our minds so that she's referencing the ballers instead. Because in this case, it's the ballers that are the children.
Aww.
Let's apply her words against the ballers, the priests, the idiots.
That's a tough one for them. They have to remember density, no matter how well you drill density into their heads. They still have a problem with that. So,
yeah, he is definitely cherry-picking this.
So this could actually be used as a density demonstration as well as a gas law demonstration.
There you have it. They've got to remember density. No wonder, no matter how much you drill density into them, they still have a problem with it. It's because we've all been brainwashed as a child to think that everything was caused by gravity. And now she's ramming it into your head and telling you that it's a problem because people need to remember it. And guess what? Everyone's forgotten it, haven't they? They didn't know about it because they've been brainwashed with gravity bullshit from people like the Rumpus. It is.
It's not just people like the Rumpus. It's people like every single physicist out there. So it's not like this fringe group that says gravity.
Thing. It's not just a measurement. It is a thing. Is it a force? It does seem to cause movement, doesn't it? F equals ma. We change the volume or the density.
Yeah. So he said F equals ma a few times, but I don't think he knows what he would plug in for each of those. Right? What would he use for acceleration? Right? Where's the acceleration coming from? That's coming from gravity. But he says it's not there. So where does that come from? So, B-ball for life. You can't have buoyancy and density without a downward force, of course.
It's going to make it a different density, isn't it? And then what do you know? There's displacement. So relative density must be more than what you're telling us it is, guys. It's got to be a thing. And you.
Oh my goodness. All right. It's about buoyancy. It's hard to. He just keeps going on. Oh, I invited the 24/7 folks to the stream. DJ Torque says, okay. Well, if Sheckelson shows up, that'd be great. So, what school did Riley go to? I learned about density, volume, buoyancy, and gravity, not just gravity. That's a good point. He's been told buoyancy. He's been told the formula for buoyancy, and he just ignores it because he can't accept the outcome, right? So. Whatever. The key is you have to somehow discredit all of this. But gravity isn't a force. But gravity is a force. So I don't know, Chris, how you get gravity isn't a force without some supporting evidence. So try to come up with something to support that claim. The question that really it all boils down to: does mass attract mass? And if it does, we can call it what we want. Call it gravity. Call it the force of mass attracting mass. But it is observed, and the actual mechanism by which an observation happens isn't necessary to understand. It's nice. We're curious. We want to know why, but we don't have to know why. It's fine to not know why. But I have a couple things that are very nice. This fantastic experiment where they used 13 tons of mercury. It's really cool. Let me see if I can. Yep, I'll get it up here. Reflections on a measurement of the gravitational constant using a beam balance and 13 tons of mercury. That is a lot of mercury. And they borrowed it. So I read this whole thing. It's a pretty good. It's about measuring the gravitational constant. It's not about testing whether or not gravity exists because that's already been figured out, really, right? Only a few flat earthers say that gravity doesn't exist. So Gary Wabenga, Marvel Girl, most of my videos show what I'm saying. I've watched some of your videos. They're no good. So, Chris Berry says Einstein says gravity isn't a force. Okay, Chris Berry. Let's play semantics? No, I'm not going to play semantics. So here it is. You see this position T, which they call position together. And that those four squares or rectangles represent where the mercury is, right? And then there's the upper test mass. And I hope you can read that. And the lower test mass. And I'll zoom in a little bit here. So we've got the together position with the upper test mass and the lower test mass. And they measured the force of gravity, or the downward acceleration, right, on both of these masses here. And then in this other part, they moved the mercury up for the top part and down for the bottom part, and then measured the force again. And so what happened was the mass in position apart, or at position A, that test mass had a lower force pulling it down, and the bottom test mass had a higher force pulling it down, measured. So, Chris Berry, what would cause that effect? This was done in very particular conditions. They were extremely, extremely careful on all this stuff. Read the whole article. I'll get it in here. I'll put it in the chat here. If you're serious, Chris, I think you might want to read it. 13 tons of mercury. You could poison the Atlantic Ocean with that. Yes. So they actually borrowed it for several years and then returned it back to some university or something that they borrowed it from. And they actually loaded the mercury into the big vessels, which were stainless steel vessels, under a vacuum so that there would be no contamination in there. It's pretty cool. The reading about all of the details that they did to do it. So buoyancy doesn't make things accelerate. B-Ball for Life says buoyancy doesn't make things accelerate. It's a force. Force makes things accelerate. I don't know why you'd say that. So anyway, they measured a difference in those forces, right? Or the acceleration, if you will. So that's one. And if you can't explain, Chris or Gary, how that changed, right? Because it's not touching the mercury. It wasn't in contact with. The only thing that changed was the location of the mercury. So the mad philosopher, how powerful was the vacuum? It was as powerful as 2 high-quality Dyson vacuum cleaners. I'm kidding. I didn't. You could read the article, read it in there. Let's see. So there is another one here. I love these. When people like. They haven't done this. They haven't replicated Cavendish in a lab. People have actually said that, and of course they have. They do it all the time. You can buy your own. So let's see. This is another determination of the Newtonian constant, G, the Newtonian constant of gravitation. And here's the apparatus they used in this one. They have these masses in these small masses and these large masses, and they're measuring the twist on something. So yes, Globebusters has confirmed a 15-degree drift. So let me keep going here. I have another one. I actually, my favorite one. Oh, it's on my gravity page. I have a page on my website. On gravity. I'll put it in here. I should update. I have a little more things to put in there. But it has 2 more experiments that were both torsion balance experiments. One at the University of Washington by, now I'm going to say this name wrong, I'm sure, Jens H. Gundlach and Stefan Merkowitz. So, all right, Gary, seriously, the horizon is the primary flat Earth proof. Do I need to show you a curved horizon? If I show you a curved horizon, will you come on my channel some Tuesday night? How about that? All right, they measured the gravitational constant G. Now this one is a very, very well-controlled experiment. Here is the apparatus diagram. They have the large balls on the outside, and then on the inside there is a plate. They're using a plate instead of small balls on the torsion wire there. I hope that's clear. Because they were able to more accurately calculate it. Yes, DJ Torque, I should hunt down the people that performed that experiment and have them on the channel. So one of these two guys is currently working for NASA. So I do like NASA. But I have a feeling that like it basically automatically they just ignore it. But so whatever. Anyway, so the inside of this chamber is a vacuum, and that's the part that moves. The outside of the chamber does not move, so the vacuum doesn't affect it. And then they actually use that torsion wire. If you look at that torsion wire, one of the challenges with accurately measuring the gravitational constant is having an accurate idea of the amount of torque that is applied to that torsion wire and exactly what that means, right? How much torque twists it, how much. So what they did is they actually rotated the entire apparatus on a computer-controlled, like just a record player, basically. It's not a record player, but it's a very, very well-controlled one, so that they could to measure the torque, so that it didn't they didn't need to get, because what happens is as the torque changes more, right? It changes more and more. That farther torque it gets more and more uncertain, right? So that they only let it torque a little bit, and then they twist the whole apparatus while it does that. Gary QED says, Gary, the horizon is a circle around the viewer. It is, of course, level, you dipstick. Yes, dipstick. It is flat, not level. Or level, not flat. Jeez. So, again, Gary, I've asked you. Come on, man. But I can show you a curved horizon. So, I need your word. You're going to come on the show. So, and yes, Chris, I just do Tuesdays because, like you, I have a wife and kids. And so I schedule every Tuesday to have time. Of course, I could do a different time. But we have things on different nights of the week. I coach on Mondays and Thursdays, so that leaves Wednesday as the only weekday open, which we're usually doing stuff. You are a coward. Why do you have time to sit here and not go in with MC Toon? I agree, a Marvel girl. You are fantastic. So just my email address is mctoon@mctoon.net, and I'll just send you a link quick. Level is always flat. It's not, actually. I can show you a picture, but you got to come on. So, all right, next one here. This is a Chinese experiment. And, oh my goodness. There it is. You can see all of the names of the researchers here are Chinese. So let's find, there we go. Another similar looking thing here. And this one, they did two different apparatuses here, I think. And they had two different very close values for it. So again, it's in a vacuum chamber. Again, they're using a plate instead of a ball on the torsion bar. So, no, Chris Berry, I don't know if she's talking to you or Gary. So, Chris, I understand you have your wife and kids and whatever, and maybe they're sitting next to you watching TV while you're on here, and your wife's like, "Get off the phone," whatever. I get it. I get the same thing. I have a lot to do. I have kids. So, all right. So here it is again. So those are on my website on mctoon.net/gravity. And now it is officially past time that Ron Sheckelson should be here. But he's not. Not on Discord. So Gary says, Marvel Girl, I understand what I'm looking at. You have to be told that what you see isn't what you see. Hard time parsing that. Yeah. Gary. So Gary, it's like your misunderstanding is so big. So yeah. All right. Yeah. So it's not looking hopeful for Mr. So LIGO. The LIGO experiment. More on gravity. Yeah, Gary makes no sense. So, oh, you know what? I don't normally do Wikipedia, but it has a nice list of, let me see if I can, the first observation of gravitational waves, and then it has a list of gravitational wave observations. I love this one. Let me adjust things quick here. Gonna move that up a little. There we go. Transition. Looks good. All right. So here is all of the different things that they've identified with both the LIGO and the Virgo. Is it Virgo? A detector. Yeah. And all but a couple were identified with both. DJ Talk, why don't you watch videos from Ron's channel in the meantime? Ron, oh my goodness, Ron Sheckelson? He does have some. You mean a Flurf didn't keep his word? Say it ain't so. Yeah. He didn't show. I don't get it. So yeah, all right. He has some oh my goodness. I've been to his channel. Gary, my poor old table is lumpy on top, but shockingly enough, it's still level. Level doesn't mean flat. Yes, let's pick Ron's channel apart. Maybe he deleted his channel? I don't know. Where, there, all right, found it. He has 629 subscribers. And just a few videos. Cold Moonlight, of course. Of course, Cold Moonlight. All right, so let's see. Can you hear this?
Okay, I got 44 degrees on the top of this car. And there's the moon. The moon out tonight. Between 44 and 45 degrees. Now I'm going to move it to the side of the car. 55, 56 degrees. 60 degrees, 61. Upwards of 61 degrees. On the side in the shade. And the closer up I get to the top, the colder it gets. There's the top of the car right here, 44. Now I'm going to go down the side of it.
All right, so we can't see anything. We don't see what he's pointing at, so I don't quite understand what he is actually claiming. But here's the key, and what flat earthers always miss is you have to control your experiment, which means you'd have a test and you have a control. So if you're suggesting that the moon causes it to get colder, you do it in the full moonlight, and you take the difference between the moonlight covered area, right, and the non-moonlight covered area, and you subtract those two and you get a difference. That's your test. You have one test now. And then what you need to do is you need to do it when the moon's not there. So you come back 2 weeks later and you do the same thing, and you measure the same areas that have the same exact everything else the same as much as possible. Even wait until the ambient temperature is the same. But if there's anything above that area, yeah, Greater Sapien did this too. If there's something above the area that was, the shaded part that was warmer and the part that wasn't, you test that again, and then you measure that again. You subtract the two, and that's your control group, right? You need both test and control. And if you don't do a control, you don't know. You have nothing to compare to. So you need to do both. Another thing is, and the explanation for why it's happening is pretty clear. It's actually, I don't mean it's a little bit complicated, a little bit hard to understand. But if you have if you're measuring something, and directly above what you're measuring, right here is a shade, right? The heat can't get out, right? It acts as a bit of an insulator. So you could wait until 4 a.m. or 5 a.m. when everything has had more time to equalize. Then run your experiment to get your test. Then 2 weeks later, run it to get your control. So yeah, those infrared thermometers are highly inaccurate. That laser that it shines out isn't actually doing anything with the measurement. It's just an approximation of what you are measuring. So something like a quality mercury thermometer or alcohol thermometer would be a little better. So that's enough on that cold moonlight. So let's see. Oh, he has a few of those, doesn't he? Solar eclipse with the P900. So what's he gonna? Oh, it's his screen. Quality. Oh my gosh. So, all right. I hope he's not going to say there's two moons. You see that? That's a lens effect. So this is, what is this? This is his a P900 and then a phone camera looking at the little screen on the P900. Couldn't you get the footage from the P900 directly? Oh. I don't know if he has a point here or not. He's overexposed. Yeah, all right. So he didn't really say much. Fake flat Earth comment challenges when clicked on. 25.
I was watching a video
seconds.
about a gun, and I came across this comment that looked totally random. Flat Earth is 100% true. The globe is easily debunked with any kind of scrutiny. And then when I click over here, check this out. It changes the comment. Isn't that strange?
Isn't that strange? All right. Oh, I watched this one. Proof that commercial airplanes fly much slower. Commercial airplane flies low and slow. Oh. Vertical video too. Thank you for that. So I don't know how this is proof. How is he measuring anything in this? Ron, you got to do better. This isn't anything. It's far. When it's far, it appears to go slower because it has more distance. Chris is gonna join. Well, send me an email. I don't want to put it into the chat unless you're on Discord. You can. But my email here. mc2.net. Yeah, the stupid airplane vids. I don't understand the they want to like Yeah, Marvel Girl and La Cerveza Más Fina. Did I get that right? The last beer. And I'm gonna have to create another one here. So guest group. So Chris, I don't know if you sent me an email yet or not. There it is. So sent you the invite window. So I'm setting up OBS to work here. So talk amongst yourselves. You gonna be on screen, Chris? So, all right. That should do it as soon as he's in. So, but we are looking at this goofy video. Probably not. Oh, probably not on screen. Okay, that's fine. Whenever you're ready. This, yeah, so yes, it's just the same thing, right? So it's far away. Its angular distance that it moves is not something you can really qualify like that or quantify like that. Yeah, and again, this is a different video, but this is proof. So we got proof that commercial airplanes fly much slower than we're told. Don't know how that's proof, but YouTube is duplicating comments. Artificial intelligence strikes again. Oh, April Fool's Day chemtrail spraying is real. No, it's not. Slow flying airplane passes. All right, he's not gone. So I sent it from Google, but I like they're supposed to send it directly, but I'll reply to the email there for you. So back to his video. I have what? Strange phenomenon revealing moon phases with Nikon again with the phone camera on the.
It's May 7th, 2019. I'm filming the moon through my P900.
Would you like some candy?
When I snap a picture, it reveals the whole shape of the moon.
Can you hear me?
Whatever it is that's
Yes,
in front of
Chris.
the moon,
Hey,
I'm
what's
not
up?
sure, but the camera's picking it up. If you know what's causing this, put it in the comments.
All right, it's Earthshine, is what it is. All right, so Chris is in. Let's do a. Say hello, Chris.
Hello.
There we go. Looks like I'm seeing your audio and they can hear it. So
Great. What do you use, OBS?
I do, yeah.
Okay, I use OBS. It's a complicated tool to learn.
It is, yeah. So Oh, let me see. I'm going to try to resize a little bit here. There we go.
So how did you hear about me? Because when I came on your channel a week or two ago, and you saw my name in chat, and you knew who I was, but I honestly I'd never heard of you. I don't know how I came across your live stream at the time, but was you see me on not.
Yeah, I saw you on Non Sequitur with I don't know, who are you on with? Team Skeptic?
I've been on with Godless Engineer, Fight the Flat Earth, and then Godless Engineer again with Kyle.
Okay.
I was on Team Skeptic show a couple times, yeah, afterwards.
All right. So, and you gave your background, I think, a little bit on one of those. Do you want to say anything about what your background is? Or what you do?
Yeah, I mean, it's basic. It's just a basic flat Earth story. I came across it on a YouTube video, and honestly, it's been so long. I don't remember if I came across it like on a suggestion, or if I heard someone like Eddie Bravo talking about it on Joe Rogan's show, or what. But something like that. And of course, I watched the video, Eric Dubé's 200 proofs Earth is not a spinning ball, and I don't care who you are. I mean, one of the 200 proofs is going to be intriguing, right? And if you say it's not intriguing the first time you watch it, you're lying, in my opinion, right? I mean, there's some things on there you watch, and even if you said, "Oh wow, I wonder what the heliocentric answer is," right? You still went to look for the answer, right? And that's kind of the thing that got me, is I had to go look for the answers because I didn't know. And really from there, I just did all the research. And of course, people say, "Oh, well, YouTube, huh?" But like, yeah, I watched a lot, like hours and hours and hours of videos on YouTube, and did research online of those things, research on gravity, research on the formulas of curvature, or all those things. So, long story short, that was 2.5 or 3 years ago now, and yeah, I mean that's really it. I mean, I could keep going, but it's a basic flat earther story, I believe.
Yep. So yeah, I watched 200 proofs. It took many sessions because I fell asleep, and then I fell asleep again, and then his voice gets a little drony. You gotta admit, like him or not, that voice. So yeah, every one of those I saw, I'm like, that doesn't make sense. I don't know if that's true, and when I looked it up, I'm like, oh yeah, that's not true.
Yeah, fair enough. But again, it made you question enough to say, "Oh, well, I want to see what the real answer is," because even if you said you don't believe his answer, you still had to go and look up the quote unquote correct answer yourself, right? I mean that's the point.
Sure, for some, yes, absolutely.
Right. So I mean, there's things on that video to this date that honestly, and I'm speaking non-biasedly as much as possible, or unbiased, whatever the word is, that there's things on that video to this day that I don't know what the true answer is. Like, for example, the horizon rises at eye level. I do not know what the truth is, because I've seen things from ballers that show it not rising, and I've seen things from flat earthers that do show it rising. But there's a guy named Mind Warped. He's in Australia, and he's got a drone that he takes up like 400 or 500 meters or whatever it is, and the horizon absolutely rises with the drone, right?
So
I'm like, well, how?
The problem is that's not very well measured.
Well, no, of course not, but none of them are.
Oh no, there's plenty that are well measured. Right?
Well, they're well measured, but there's no validation or verification. Like the ones I've seen that use like those water levels and things. Okay, that's good. It's a good interesting measurement, but what else could be at play, right? For example, refraction. We know refraction can cause things to be hidden, so to speak, around a curve or in general, and that's called what was it? God, now I forgot. I'm tired. It's almost 10. Atmospheric shrink, or refractive shrinking, or no, sorry, sinking. So there's a refraction term called sinking, and to give you the unexact and definition. From what I remember, it's basically refraction pulling things down to make them disappear out of sight, basically. So my point is if you saw something at the horizon, 20 miles away in some of these videos, and it doesn't rise, it could just be refraction.
It could be. All right, so let me see if there we go. So here is do you see that there? This is on my website here, mc2.net/horizon does not rise to eye level. It's on just on the main page if you want to scroll down.
Sure.
So here is a
wait
setup.
Wait a second. So we're supposed to believe the horizon should be where the top of the two red water lines are?
No, not at all. This is the setup.
Oh,
right.
Okay.
This is the setup. This is just a close up of the setup. So this is by Bobby. Oh my goodness, why did I forget his last name? Bobby Shafto.
Okay.
He did this. He lives down somewhere near San Diego. So this is off somewhere in San Diego, and you can see these islands in the background of the Coronado Islands. So here's how he did the photographs, right? He had a camera there on a tripod. He had the tripod holding up the water levels. So now here is from 90 feet the tops of the water is lined up, and you can see the horizon didn't rise.
Well, okay, but it's semantics, because it does rise. It's not maybe the answer is it's not rising to eye level, but it does rise. If you lowered that camera, the horizon would lower, and if you raise the camera, it will raise. It's like I've seen comparisons of people on ground in a plane, and then that same person in the air, 35,000 feet, whatever, and the horizon is at the same level it was when it was on the ground. So how would you explain that?
I would explain that they didn't measure it well, because on the plane they didn't bring any equipment to do a quality measurement. Right? I've seen plenty of people just point a camera out the window of a plane. But I have also seen people use the Theodolite app on a phone, and the horizon doesn't rise. And I've seen people bring, like Planer Walk actually brought a small level with them on a plane and use that. It's much less quality to have a small level, right? Because the margin of error is a little big. But at that height, it's enough of a distance that even with the margin of error on a small bubble level, you can see it. Right?
So do you know? Okay, so I'm going to ask you a question. Okay, where is the horizon in the image you have on screen right now?
The horizon is below those two red lines, and you can see there's a ship. The horizon is past the ship, and the horizon is before the Coronado Island there.
Okay, so let me ask you a secondary follow-up question. How do you know that's the true horizon?
Well, are you going to say that there may be some optical effect that's making us not see the true horizon?
Yes.
Yeah. So that would be this image, as well as others that Bobby has taken, where you can see things behind. This one isn't any, but this is the same day, I think, as that one. But let me see. This is a different day here, and yeah, this one's good because you can see the texture of the clouds below the true level there. So in the sky, you can see the texture of the clouds.
I mean, is it zoomable, or like can you zoom in on it?
This is as far as this particular image goes. Yeah, and he uploaded these. He has higher res of these. I should ask him for these.
I'd like to see them zoomed in, because honestly, like right now, if you look at that mountain that's kind of in the middle to the left, it looks like the bottom of that mountain is missing. Like you can there's a distinct clear line below,
sure.
and then it's and then darker.
Yeah, but that's also quite a bit below the true level line there that he has in the middle of the that grid box.
Yeah, fair enough. But I mean, what one thing is telling me is that there is refraction at play, and then two, what I do know for a fact is refraction gets worse the further out you go, because obviously if you have a column of air that you're looking at, right, that air is going to just become more. It's become more. The air, the density is the same, but because you're looking through more of it, it's gonna be more dense basically. So,
now
what
does density do?
It's going to make refraction worse.
Yes. And what happens when you have a refraction in air, right? Because we have from altitude, and this is taken from 100 feet. What does the density gradient do?
Wait, so
to the light?
What is the density? Well, it depends on the temperatures and those kind of things.
No. So let me rephrase as, what does an index of refraction gradient do? If the index of refraction is lowest at the bottom and increasing and decreasing, I said it wrong. It's the highest value at the bottom, and it's decreasing as you go up, right? So it's the lowest. I kind of messed that up saying it, but. You understand what I'm saying? Should I say it more clearly?
No. Well, so no. Why don't you just tell me what honestly, I hate, and I'm not calling you out, but I have people ask, like Bob, the science guy, does that, and it drives me nuts. He'll ask you a question, waiting for the answer. Like, just tell me what you're getting at, so we don't have to, play the cat and mouse game.
So here's some numbers. The index of refraction, just kind of the standard that they use, but it's of course varies quite a bit, is 1.00029. At standard conditions for temperature and pressure, which they've defined in this table here, right?
Okay, sure.
So it's just agreed upon standard. It's sea level. It's a certain air pressure, certain humidity, certain pressure.
Okay.
And then the difference, and then up high, as you go higher up, it goes to 1 or very close to 1. And that's not a big difference in the index of refraction. But when you go through a farther distance, a long distance of it, it makes a change, because a very small angular change over 10 miles adds up to being a lot.
Yeah, well, that's basically what I was saying, is that when you look through 1 mile of an air column, it's not bad. You look through 10 miles of that air column, it's much worse.
Yep. So here is Batman looking at a building here. This is with no air basically, or no change in the index of refraction. Light would go straight. That same light ray, though, if the index of refraction were how our atmosphere is, where it's getting lower or getting more a higher index of refraction, as you go down, it's going to bend that light towards the higher index of refraction. That's what it does, right? So then there's a different, so that original light beam wouldn't make it to Batman's eyes. It's going to, curve and go off before it gets to him. So that the different beam of light that actually started out at a different angle is going to be what gets to Batman. Are you following along there?
Kind of, not really from these pictures, just what I already know. So he's saying the top line will get to him, but the bottom line isn't going to get to him?
Yes. Okay. Yeah, because it all curves. So the original light beam from this one with that straight line, and I hope it shows straight on here through Hangouts. That one wouldn't make it because it's going to curve down and hit the ground or something in front of him. And then you've got a different light beam that started out at a different angle, slightly higher, that otherwise would have missed him. That's the light beam that's going to get to him.
Okay, well, so is this on a flat surface or a curve?
It doesn't really matter if it's flat or curved.
What's the distance between Batman and the hotel? Because the hotel would have to be like many, like 20 or 30 miles away for him not to be able to see the top of the hotel.
Well, he can see the top of the hotel. There's no problem with that. It's that the light beam, the light that originates from the top of the hotel, has to start out at a different angle in order to get there. Right? So the top light beam, and it is a slightly higher angle than the bottom light beam, and that's what gets to his eyes because of the.
Can you go
curve.
back? Can you just do me a favor? I don't know how much more time I have. Can you go back to that picture of the real picture we were looking at? I noticed something interesting on that picture of the horizon and the table, or the square and all that. The square box with the lines, whatever.
Yes. Yep.
So I noticed that it says, click on, so I noticed on the right it says apparent horizon. What's the apparent horizon?
That's what you see. So he's being fair and saying,
Okay.
and not calling it the horizon. He's calling it the apparent horizon. It's what you're seeing.
So why would it only be an apparent horizon?
Because he's being fair. He's not just saying it is the horizon. He's using words that are not going to cause people to have an issue with the word of horizon, instead of the point of whatever it is that we're looking at didn't rise up as is claimed.
Okay, so I mean, I then agree with this observation that the eye level is higher than the apparent horizon.
Yes.
So then the question is it the apparent horizon or is it the real horizon? And then how do we verify that?
Well, yeah,
claim?
and that's the question. And so that's why I'm doing this. We're looking at refraction here.
Sure.
So, if let's see, we're looking at.
So can refraction cause things to go up and down?
Refraction does it absolutely, but
Okay.
for the most part, under calm conditions, it's a gradient mostly, from top to bottom, that doesn't have a lot of inversions. Okay, so when there's an inversion, then it starts throwing things off. Or if you have windy conditions and a lot of heat and the sun beating down, stuff like that, it can make all these things a lot more chaotic and makes observations basically so much in question that you can't really draw any conclusions. So it's best to have conditions that are not sunny, because that causes the causes the heat to come off of the water a lot. Yeah.
Can I share something?
Sure.
All right, let me share my screen.
All right, hold on.
So this is a picture that I took a snippet off of a video on YouTube that I can send you the link if you need it. But I was basically comparing the different sizes and shapes of the boat as it got further out. So I want you to notice, and by the way, can you see it first of all?
Yep.
Okay, so let me just zoom in a little bit. So there's a lot of things about this photo these photos that are really cool. But to this point, notice that on the image you were showing, I asked where the horizon was, and you said basically it's the hard quote unquote water line, or the blue water line. And then I asked how you knew it was the real one, and that even on that guy's picture it says apparent, and that's good because that's correct, because we don't really know, looking at those distances, where the real horizon is. And this video and these images show that perfectly, because you would just assume if these black lines weren't here showing where the inferior mirage starts, that, and if this boat wasn't here, you would say, oh, here's the horizon, when in fact the horizon is this much higher in the photo. So that,
well, I would say we don't know where the horizon is.
Well, I know where the horizon is. Right, it's where this black line is, because that's where the boat is right. The boat is rising because of perspective, and then basically you take the image, and the further it goes, and you basically at this point you're going to cut it in half. So here, because it's rising, here's the horizon, because we see the boat is on top of the water here, and then it's still on top here.
Yeah, but I would say, and it doesn't matter much, but I would say that it's somewhere between the apparent line there and the line that was drawn in, that it isn't actually at the line that's drawn in, because there's too many atmospheric effects that are happening there. That we don't know if there was some reflecting happening as well. Well, we do know there's some reflecting because of that inferior mirage. So what this does is that it puts the observation into question. And so when you look at something like this, you say, okay, this is the wrong day, the wrong conditions. Let's come back on a different time and have better conditions so that we can have less of this chaos.
Yeah, so that's another one of my pet peeves, because to me, there's never going to be... So the norm is these conditions. The not norm is quote unquote good conditions, right? I mean, you're always going to have atmospheric refraction, especially over water. Like, it's just going to happen. And the further out your object is, again, the worse the refraction is going to be. The worse the haze will be, the worse, right, the disappearance of the object will be, etc., due to the atmosphere. So it's just one of those things where I'm like, you can't get around refraction. You might try and find a day where it's less, and that's fine, but you see what you see with refraction.
Yep. And so that's why, in general, I really don't prefer using optical things over water, because for everything that you can find that looks flat, I can show you something that looks curved, and in the end we make no progress because it's just this back and forth.
Right, but you're using those level experiments over water to prove that the horizon doesn't rise to eye level. You see the problem with that?
Well, I was simply refuting, because you started talking about 200 proofs, and so I went to number 2, which is, the horizon rises to eye level. And in fact, I've never seen it once measured rise to eye level. So if you've ever seen it measured rise to eye level, I'd love to see it.
Well, but you're saying even measured, we don't know if that's the real horizon, and
correct.
This image proves that. So why are we using that as an example at all?
Why is exactly? Why do flat earthers say that? Why does he not take it out of his video? His channel was deleted. He re-uploaded the same video, and he didn't take out that bad measurement, that bad claim. It's his claim number 2. And so it is just demonstrably false. Never does the horizon rise to eye level.
Remember, I started the conversation by saying that I don't know the truth, because I do know the horizon rises, but to what extent? Is it not perfectly to eye level? Okay, maybe, but does it rise? Yeah, it rises. And if you say it doesn't, I mean, that's just false, right? So like you said, maybe it's somewhere in the middle. But again, you have it on your website as a proof. He has it in his video as a proof. So
I have it as a disproof.
And you have it right. Yeah. You have it as a proof that the horizon doesn't rise.
Yeah, and that's because it's just such a often repeated trope. So, so my point really is, don't use it. It's not useful. So.
Well, but I would say, and I hope you got my point in all this. I would say the same thing to you.
What?
Not to use those photos of those water levels staring out over the ocean.
Sure, let's move on.
Are you going to take those off your website?
No. As soon as Eric Dubay stops making the claim and other flat earthers stop making the claim, it'll be useful until then. Right? But because it's easy to just say, look, it never rises, and so you can't actually you can't use that as a proof for flat Earth. At best, it's a nothing, right?
You can't say that again. You can't say it never rises.
I've never once seen it rise to eye level when it's been measured. It rises, absolutely. Okay. But it doesn't rise to eye level ever, ever. And so as long as Eric Dubay is saying it, I'm just going to leave that page up to say it doesn't rise. So move on to something more meaningful, right? Make sense? I'm happy to leave it, because observations over water is subject to aggressive refraction. So.
Well, right, but see, I feel like you're either making my point or missing my point, because if the point is that there's major refraction over water, but you're using evidence over water to prove the horizon doesn't rise, then isn't that sort of hypocritical a little bit.
Well, we didn't get through my other point, which is about refraction, and that refraction will cause things to appear higher, which is a double blow.
No, but not according to the image I just showed. It made the apparent horizon lower.
Yeah, and I'm talking about in non-chaotic conditions.
Well, but why are those conditions chaotic and in yours they aren't? Like, what proof do you have that of that claim?
Well, we know
that to me is just a boat on the water on some sunny day, right? I mean, why is that chaotic?
Oh yeah, because people understand what causes aggressive chaotic refraction effects and what doesn't, right? We know that a sunny day causes heat right over the water and sets up reflection layers and aggressive refraction effects. So that's a something you don't want to use, right? So let's move on from that then. What do you have that makes you think the Earth is flat?
So my big thing is ground level observations and measurements. I don't go to the sky. I'm not, like, if you were to ask me, how does the sun work? How does the moon work? Well, I could give you the standard flat Earth answer, but that's just not it's not my interest. It's not what I've researched. I don't really, I just don't, that's just not what I do. But basically, the ground, ground level, water level, whatever you want to call it, sea level, observations, measurements. Like, for example, one of the last tests that one of these flat Earth groups did in California was they did two 18-mile or almost 18-mile observation measurements. They used a standard laser light, and then they used the mirror reflection, almost 18, like 17.65 miles. If I'm not
okay, so hold on. We're moving on from observations of light over water.
Well, but you asked me why I thought the Earth was flat.
Yeah, but we had already decided that observations of light over water was not going to be conclusive, so we should not use that.
Well, they've done laser tests over land too. I think I'd have to look because most of them are over water, because people, because over land you could argue, well, it's just like hills and mountains and things.
Yeah,
but over water, the water is either flat or it's curved, right? There's minor undulations, say, in the waves, but in theory, it's either a curve, or curving away, or it's flat across. So I think that's where a lot of people were going for the water tests.
Okay, so do you have something that's not light over water?
That's not light over water. Let's see.
You can't have just like one thing, because that's the deal. Light over water is one thing, and when you're examining something to find out what's going on, you build up your proof, right? Your different evidences, not proof.
Well,
you
have to realize that to me is one of the it's more interesting.
But it's only one.
Well, no, it's not one. It's many different pictures, videos.
When you do science, you take a whole bunch of measurements of the same type of experiment. And that's one thing, right? And then you take a different type of experiment and you do a whole bunch of measurements, and that's another type. Now you have two things, right? So, and you put them into the bucket that supports or doesn't support. So, observation, lasers over water. Yeah, that's what all the flat earthers want to do. And it's one thing. At the end, even if it works right, even if it's well controlled, you have one thing. So what about other things? What about gravity would pull a flat plane into a ball?
Well, see, and that's the thing is, I'm like, I can talk gravity some, but it just doesn't interest me. It's another one of those things where, to me, we're basically at a stalemate. There's no scientific proof for gravity. There is an effect.
Hold on.
But it's
hold
only
on.
one
Hold on. Just wait.
thing.
Just wait. Name one thing that's been scientifically proven.
Water boils at 100 degrees centigrade at 1 atmospheric pressure.
That is a definition.
What do you mean it's not?
They decided that let's boil water, distilled water,
they didn't.
and look up the history of how the centigrade scale came to be. They boiled water, and when it boiled at 100, they marked it 100 degrees.
So you don't think that someone somewhere came across a hot spring, a natural hot spring, and said, wow, I wonder why that hot spring is boiling like that, or steaming, or whatever they do?
That has nothing to do with how they defined the centigrade scale. They defined the centigrade scale by saying, we're going to choose something that everybody can replicate. We're going to take distilled water at standard pressure, and we're going to boil it. And then we're going to put a mark on the thermometer there, and we're going to call it 100 degrees. It's arbitrary. Then we're going to do the same thing with the same water at the same pressure, and we're going to freeze it. And when it hits 0, or when it freezes, we're going to mark 0 on there. And then we're going to put 100 even lines on that thermometer. That's how they got the centigrade scale. So it's not proof.
I think you're missing my point.
No, it is not proof that water boils. It's a definition. It's an arbitrary definition. So that's not a scientific proof. So what has science proven?
Well, so I don't agree with your analysis. So I come across a hot spring. I wonder why it's boiling and steaming. I then make a hypothesis that what I know about heat and energy and those kind of things, and I say, well, I wonder that if I heat this water, will it boil that same way? And by the way, I wonder how hot it has to be to boil. So I can make a hypothesis, and just for sake of time and argument, I'm going to say if it boils at 100 degrees centigrade, or if I get it to 100 degrees centigrade at 1 atmospheric pressure, it will boil. I then perform an experiment to test my hypothesis. I put it in a beaker. I turn the beaker up. I put a thermometer in there, and then the second it hits 100 degrees Celsius, it starts to boil. So I have a natural observed phenomenon of the hot spring boiling. I have a hypothesis as to why it boils. I have an experiment based on the hypothesis, and then I have my confirmed results based upon the temperature that it hits when it starts to boil.
All right, none of that matters. None of that matters because the Celsius scale was defined by putting a mark where water boils and a mark where water freezes. It's a definition. It's an arbitrary definition that they just made. So you cannot prove that water boils at 100 degrees. That's not been proven. It's a definition. So what has science proven?
So by that logic and argument, then there's no measurement ever taken that's accurate or can be proven. It's just based on your
absolutely correct. You got it right. There is nothing in science that has ever been proven.
Okay, so what's the point of all this then? I mean,
so I just want to have a
ground or flat.
I just want to have a common understanding, an accurate understanding between us, because a lot of flat earthers like to talk about proof. You don't have proof of this, you don't have proof of that. We don't have proof of anything, and we're happy that we don't have proof of anything because that's not what we're looking for. Science doesn't prove. Science can disprove, and science can build up a lot of evidence. That's what it does.
So you have no proof of a spherical spinning Earth, then, correct?
Correct. I have lots of evidence.
Okay. Well, I have lots of evidence for a flat Earth. Then.
Okay, good. So we're on the same, right? We're talking how science talks and not how, you didn't prove this, therefore you got nothing, right? And so the other is people talk about theories and they're like, oh, it's just a theory. It's not just a theory. So a scientific theory is a rigorous thing that has come up after lots of experiments that's been pulled together. So when somebody says just a theory,
though, right?
Of course it's not proof.
Okay.
But a theory doesn't come about just haphazardly, and it's not a hunch. And so when somebody says it's just a theory,
well, it is a hunch. It is a hunch based on the apparent.
No. In science, a theory is not a hunch. There's no correlation between them. Then you don't understand science.
No, I do understand. It's a hunch based on the evidence observed. It's a guess based on the evidence observed. You just said there's no proof in science, but now you're saying that it's evidence based on what? Proof?
No. Just a second. Just a theory. So there it is. an article here. I like this one. I'll post it in chat here. Why anyone who tells you science doesn't prove things and partially doesn't understand science. Now, we've moved past that, so that's not important. But I just thought I'd add it. I have too many references here. A scientific theory is an explanation of some aspect of the natural world that has been substantiated through repeated experiments or testing. So, there is no...
What experiments have they done with evolution?
All right, so we're just defining terms at this point, okay? So I put in, that's from Scientific American, an article in there that goes over seven different things in science.
Sorry, can you go back and let me read it again, or let me read it again? I just want to make sure I'm clear on it.
Sure, I'll pull it up on the screen. There you go. There you go. Scientific theory is an explanation of some aspect of the natural world that's been substantiated through repeated experiments or testing. But to the average Jane or Joe, a theory is just an idea that lives in someone's head rather than an explanation rooted in experiment.
No,
or
see,
testing.
I gave
that's
you
the wrong part.
I gave you basically the exact definition of scientific theory. I said it was a guess based on observed evidence.
No, it's not a guess.
It is a guess.
It's an explanation of some aspect that's been substantiated through repeated experiments or testing, right? This last sentence, but to the average Jane or Joe, it's a theory, is just an idea that lives in someone's head. And that's wrong. That's the point of this. It's wrong. It's not a guess. And it is, in fact, something that has been repeated and substantiated through testing. So many, many experiments come together, and when they are in agreement with each other, then you have a scientific theory. Right? So they say the theory of relativity.
Yeah, I agree with that, yeah.
Okay. So the theory of relativity isn't a hunch, right? It is something that's been substantiated through repeated experiments.
I don't know. I mean, I don't know that to be true. I've not done enough research on relativity to see.
LIGO. Look at LIGO. That's a great
what
place.
What does LIGO have to do with it? I know what LIGO is. What does it have to do with it?
Because what has come out of LIGO is very much right in the middle of the theory of relativity.
They're just shooting particles at the speed of near the speed of light at each other. What does that have to do with?
No, that's maybe you're thinking of CERN. LIGO is two 90-degree lasers going over many kilometers and bouncing back, and they're measuring gravitational waves.
Yeah, but you said earlier measurements that we can't really rely on measurements because it's just an average, or no, I forgot what you call it. They're just setting the standard. So anything to do with measurements, including Cavendish, including LIGO, including CERN, we have to throw out of our discussion.
No, I'm telling you that water doesn't boil at 100 degrees, and that's proof. Water boils at 100 degrees because that's a definition. It has nothing to do with anything outside of.
All measurements would be definitions.
No. When you look, so saying that water boils at 100 degrees is similar to saying that the length of a meter is proven to be, and then whatever the length of the meter definition is. Right? There is a definition for the length of a meter. It's one of the fundamental units that people have defined. Right?
Right. So
but when
I'm 6 foot 2 inches based on the standard measurements, you're going to say that I'm not?
I'm going to say that is accurate within a margin of error, but that's not an experiment, and that's not the type of thing that we're looking at when we're saying we don't prove things. Right? So, you aren't 6 foot 2. You're 6 foot 2 within a margin of error. And if you were to find a better measurement tool, you could find that you're 6.2 something. And then that still would be improvable. We could find a different, more accurate way to measure. Right? So, but that's beside the point. I'm just saying that the point is I asked for proof. What has science proved? And you said what I knew you'd say, which is water boils at 100 degrees, and that is not proof. That's a definition. So there's nothing that science has ever proven. There's always a what if to science. Right? So what if the Earth is flat?
So these theories you're showing on screen aren't proven.
Correct. But they're supported through repeated experiments and testing.
Right, but they've not been proven, so they could be false.
Absolutely.
Okay.
And if you want to make yourself some notoriety, go pick one of these well-established theories and disprove it.
Well, there's
then you'll get a
lot
Nobel Prize.
A lot of people who don't believe in the theory of evolution. So I mean, it's not something that's new
Sure.
or that's like controversial. It's there's millions of people, including smart scientists and PhDs and people like that, who don't believe in the theory of evolution. So, I mean, I don't know what to tell you, right? It's again based. So one thing I like to say, like when I'm on Jose's or whoever, I say I'm not here to prove anything to you or to demonstrate anything. I'm here to demonstrate alternatives for those who can't think outside the box or who haven't seen the alternative evidence. So, for example, when someone says, "Look, the horizon doesn't rise because someone took a picture and they drew a line," I then say, well, the alternative could be that refraction caused an apparent horizon and now you can't see the real horizon. And then I show that with other observations, right? So, I mean, this is you're stating your case, I'm stating my case, and at the end of the day, it's just about an alternative explanation.
Yes, and the deal is, of course, to come up against things that have a lot of evidence and repeated experiments is tough to do, and the reality is that science is welcoming to that, and like I said, the people that have been the most popular scientists are the ones that came up against a popular, well-held theory and disproved it, and then those are the people that they're celebrated, because that's an advancement. Right. So
I don't agree with that, but I don't agree with that.
You don't agree that people are celebrated when they upset the existing theories? Einstein did exactly that. Einstein did exactly that, right? He came out when Michelson and company were saying it's all about the luminiferous ether, and they had done some tests and it wasn't working. They weren't finding any ether. And he came out with his theory of not evolution, his theory of relativity, and they didn't like it at first, and he had to go back and forth a lot with them, and it wasn't for quite a while until some experiments were done to confirm it. But eventually, it completely removed the previous ones, upset them, and now we talk about Einstein, and not many people know about Michelson. Now, Michelson got a Nobel Prize himself for his work on light. Even though all of the stuff that he was trying to discover about ether, he didn't succeed in. But he advanced the understanding of light so much that he got a Nobel Prize for that. So there is an open invitation to anybody to disprove. But it's not just ideas or incredulity that does it. Right? It takes rigor.
Like there's a story, and I haven't heard it in a long time. I'm trying to Google it. There's a story of a woman called, what is it? I'm just trying to see it on here. It's too long.
Curie?
No, it's recent. It's like Mary Schweitzer. She's a PhD scientist at North Carolina. She found a dinosaur bone that had living or soft tissue in it, and they, of course, dinosaurs are 60+ million years old, but you can't have soft, I don't know if to call it living, but soft tissue in a bone that old. And she tells a story about how when she discovered it, she just was basically completely panned, and she was trying to tell everyone about it. she got panned and ridiculed and mocked and all those things. So it's absolutely not true that if you upset the apple cart, are you going to be welcome? Like you have to go through an extremely arduous process and kind of a thing to be to go through that. And I mean, it's just not. It doesn't follow, right? It's like, if I can show one case where that's not true, then it's a non sequitur. It's like, well, it's possible that they're celebrated, but it's possible that they're ridiculed and mocked out of their job. So that's just
sure. Yeah, you're upsetting, and Einstein didn't have an easy time either, right? So here's Mary Schweitzer found collagen fibers in a fossil-like leg bone. They're rare and only occurred within extremely well-preserved fossils. So this isn't saying anything about any challenges that she had.
Yeah, you'd have to listen to her. There's probably videos on YouTube that you could watch or whatever. That her talking about it. Like I said, it's been a couple years since I've seen it, so I don't remember all the details, but she kind of gave a little bit of an overview and sort of how that went down. But
yeah, so she has received awards for her work in paleontology. She's been the keynote speaker and presented her research. She's been in the Nature Communications Journal for her groundbreaking work in MB and her role in establishing the field of molecular paleontology. So it looks like she's been quite celebrated.
I think that was
right. Certainly,
before.
Yeah, she may have had issues coming up and upsetting the cart, but she came out with these awards, so good for her.
Sure. But I mean, I don't know. Maybe I'll have to find a video of her talking.
Yeah, that'd be good.
It's just more apropos to the discussion, but.
Yeah. All right. So do you have anything other than observations over water?
So there's a positive and a negative claim on the table. Okay, you're making the positive claim that the Earth is round because all observation and all a natural observation is flat and stationary. So if you were to ask me why I say it's flat and stationary, well, that's just the natural observation. To make the positive claim that it's round, you have to bring proof to the table, right? In that sense, I've not seen any proof, or I guess don't like the word proof. I've not seen any evidence that the Earth is round and spinning, and moving in all these directions and speeds. So I don't know how to prove the Earth is flat. I don't know how to prove the negative, so to speak.
Yeah. So of course this is CGI, right?
Of course,
from 1972.
Yeah. When they started to do manipulation with photography, right?
Yeah. So you have forensic evidence that this is CGI.
No, not forensic evidence, but it's
okay. So you just have
you've been able to manipulate photos since the late 1800s.
Yeah. So you have incredulity. That's all you have. Right, you don't have any evidence that this has been tampered with.
Of course, there's evidence.
Where? Evidence that this has been tampered.
Or when you research like blue marble and you find out that it was 100% CGI. It's layered images.
No, this is from 1972. This is the blue marble taken December 7, 1972 by the crew of Apollo 17.
Uh-huh.
Okay, so do you have evidence that this has been manipulated?
Well, first of all, you have to prove that they were in the vacuum of space.
No, I don't. You're shifting the burden here. All I need to do is say that this is a picture that they took, and so I don't need to prove where they were or anything like that, right? You need to disprove now. This is a picture. You need to disprove.
You said there's no such thing as proof, so
yeah.
So it's not proof.
You need to disprove.
What am I disproving of? It's a photograph from a place you can't go.
Well, 3 people were there at the time.
So have you seen that? I don't know if they call it a documentary or a conspiracy theory movie. It's called, I think
Something
it's called
Happened on the Way to the Moon.
Yeah, exactly. And in that documentary or video or whatever it's called, they show those astronauts in whatever spaceship or whatever they're in, and they have their window taped off to make it look like they're taking a picture of the Earth from 100,000 miles away or whatever. And then they leave the camera on, and the guy takes the tape off and turns the light on, and you can see more of the Earth exposed. So you would have taken that photo and said, look, here's a photo of the Earth from 100,000 miles. And if that video didn't exist, we wouldn't have any really good argument, because it's a real video, probably of the real Earth. But it's not a photo of the Earth from 100,000 miles like they claim, right? So it's not an argument from incredulity. It's an argument based on facts and evidence that we have against NASA and astronauts.
I don't see how that follows. I don't see how any of that disproves this photograph.
They fake stuff. That's how it follows.
No, that's just poisoning the well, because you claim that one thing is faked, everything is faked that you want to be faked. No,
I'm saying that if one thing is fake, it's possible that other photos and videos are fake.
Of course, it's possible. Now, provide evidence.
I just did.
Right,
they faked a shot of the Earth from 150,000 miles out.
Which shot? This shot?
No,
this is the one. This is the one that you asked for proof. This is our evidence. This is evidence, and now you're saying a different picture was faked, therefore this one is faked. No. You can't say that this one is faked because a different one was faked. You have to somehow show that this one was faked.
So if you go to a car lot and you pay $50,000 over value for a car because you got swindled, and you find out when you left the lot, are you going to go back to that car lot and buy another car from that place?
Poisoning the well. That doesn't matter. You don't get to say that every single thing that I want to cherry pick from this other organization that I don't trust, I get to throw away.
Picking.
What's that?
Who's cherry picking?
You are, because you are saying that whatever evidence from NASA you want to discredit, you can discredit just because one other thing was proven to be or shown to be faked, which I don't know if it was or not.
It's many things.
It's many
things. Have
things.
you seen the videos of the astronauts on wires on the supposed ISS? You've seen those videos, right?
I've seen all of those, and they're fantastically great, and they're not wires.
They're absolutely wires.
All right, evidence.
All right, let me bring up one of the videos. We'll watch it together, and then let me see.
So the hour-long video where they're floating around and doing flips and having things floating, you need to also have that one shown. All of it is on wires.
Wait, but why are you worried? I thought you're not worried about them being on wires, so why would you care how long the video is?
It matters because you have to show that it all is fake.
So here, I'll share. Are there any cuts in the hour-long video?
No.
There's no cuts from shot to shot.
Nope. It's one solid. It's more than an hour even.
Interesting.
No, I don't have it. I don't have it on handy. Maybe somebody in has it.
All right.
Yeah,
So
I've seen this one. I've seen this one. Yeah, this isn't anything. He does a flip. This disproves wires.
Just relax. Let's just watch it together, and then you tell me what you see, and I'll tell you what I see. Okay? You ready? Here we go. It's at the bottom. What's he grabbing on?
Don't know. It doesn't matter. How did he just do a flip?
he's on a wire harness. So the guy clearly grabs on a wire or a cable or whatever you want to call it on the side of his hip. Let's just pause it right there. You can see, and it drags and pulls the pant to the side. Let's just go back. So here the pant is not sticking out at like a 95-degree angle, and you can see his hand getting ready, and then when he pulls on it, that's a bad stop. The pant goes out. Let's see if I can get a better stop. So I mean, look again. We're looking at the same evidence, and apparently we're seeing two different things. So I don't know. That's like I say, we're at a stalemate in a lot of things. It's just I see him pulling on an invisible wire. Like I don't know what to tell you. The guy visibly moves when he pulls. Like you can see him sort of jerk a little bit. So I guess you could say he like pulls on his pocket if you wanted to say that.
So you found one anomaly.
Well, no, it's not. It's there again. It's many anomalies. That's one of the most obvious ones. Like this lady's pulling on her pants because whatever she's attached to is pulling her up. You can see it move right here on her back.
But the rest of the entire rest of this video is doesn't work if they're on wires. It's just
no, that's not true.
Her hair.
Yeah, it's ridiculous. What's this guy grabbing? Have you seen this one? The guy like grabs nothing and he puts it away. Like he thinks he's seeing something. This guy right here, he thinks he's grabbed something.
Pause it when he's not holding the microphone. You see, you take this one little piece that doesn't kind of make sense to you, and you ignore that the microphone is just floating there.
Well, but no, that's not even a part of the scene. Like he thinks he's grabbing something.
There was he keep going until let's go to the microphone.
All right.
There's the hat flipping around. How did that hat flip around on wires? How's the microphone float there with wires? None of that makes sense.
You see him grabbing. He thinks he's grabbing, I don't know, the hat or something and putting it over here, and he doesn't grab anything.
Yeah. Do we have the context of the video? What he's doing? You think he's grabbing something, but you're ignoring the hat flipping.
No, I'm not ignoring it.
You are. How is that hat flipping? Where's the wires for that hat flipping?
It could be some sort of 3D animation or something, or effect.
It could. All right. You have evidence for that? So I don't go on could be.
Well, this whole situation is it could be. Like they could be in space. They could have taken a picture from space, but I mean, what evidence is there? There's two guys apparently hanging or floating, and this guy grabs at nothing and switches hands and then pretends to put it away. Like, why would he do that? This guy is pulled on a wire. This woman has wires running up at her back. You can see it here moving. Like, it just doesn't make any sense. Like, you could, I've even thought about other logical explanations. Like, they say that they send these people to space, but they don't. But they want them to feel special and say, oh, look, this person who clearly isn't looks like a computer geek, like he sits at a computer all day, is in space. Like, okay, to make him feel special and proud or whatever. They're clearly not astronauts. They're not in space. They're on wires.
See, that's all just speculation and no evidence. It's just, that video sort of looks like that, but I'm going to ignore all the other stuff in that video because it doesn't support my predetermined selection of what the outcome has to be.
What's the predetermined selection?
You've predetermined that the Earth must be flat, therefore everything else has to go along with it.
No, I didn't predetermine that. I was a ball earther for 33 years.
That doesn't matter. Since you made that decision, everything else that you've seen as evidence, you've ignored if it doesn't support your predetermined choice.
No, that's not true. In fact, one of the conversations I started, I said, I don't know what the truth is anymore because I've seen evidence on both sides, and that's the horizon rising or not. Here's another one. You can see the shirt lifting up on its own.
But what about the guy floating there? Right? You
These two guys?
ignore the stuff that is just
These two guys?
yes.
Well, they're on harnesses.
But he's the best gymnast ever to have to keep his knees up like that while he's on a harness.
Well, that's why his hand's on his leg. You see? His hand's on his knee there.
All right, so this is evidence that it's flat. So,
No. It's evidence that we cannot prove the shape of the Earth by using sources from NASA. They're shown that they cannot be trustworthy. Anyways, I don't know.
All right, that's fine. So,
ton of these videos.
So what about
Mark Sargent has the thing where he says if you prove the Earth is round without using NASA, and I'm like, I think that's fine.
Oh, I can do that.
Why would you use a government source to prove something when the governments have been lying to populations for ever?
I can do that.
All right. Hey, by the way, I maybe 5 more minutes. I know I said it like 30 minutes ago, but I'm really gonna have to go here soon.
All right. Well, then can you explain the southern celestial poles?
I mean, there's alternative. Again, it's all about, to me, alternative explanations. There's alternative explanations for it. I'm not articulate at them. I don't fully understand them. There's a guy who uses like a little glass dome thing, and he puts that over some lines, some paper, and he gets two celestial poles that way. So you could argue, well, there's a dome, or you could argue that the atmosphere has some alteration to stars and star trails. But again, it's not my area of interest. So
okay, but it's something that you maybe should address, because it doesn't have a good explanation. That there's nothing that nobody's ever explained it well, right? Eric Dubé's video on it was terrible. He made all sorts of claims that simply isn't true about what people in the southern hemisphere see, right? There's 800 million people that live in the southern hemisphere, and they look due south every day. Sean Hawkins, I'll thumbs up the video if you play the 45-minute video. No, I don't need to play a 45-minute video of the ISS right now. Crap, you interrupted me, Sean. What was I saying? The Eric Dubé made claims there's 800 million people in the southern hemisphere. They all look due south every night right? And they don't all look due south every night, of course, but when they do, they see the southern celestial pole due south, no matter where they are. So if it doesn't matter what map you take, if you take the AE map or any other map, due south has to look at the same spot. They can't look in opposite directions. I'm not showing you myself, actually. But, darn it. You didn't see my hands. Anyway, they're not looking in the same direction. And so you have a big problem there, because a flat surface doesn't explain that at all. So maybe that'd be a challenge for you to look at.
The same stuff at the same time. That's the problem.
Oh, of course they are.
No, like if you're not, let me look at a map. If you're like, what is it? If you're in Australia, and you're in
South Africa and Australia have nighttime at the same time.
They have night. Well, yeah, but
they have overlapping night.
Oh, overlapping night, right?
So they can both at night see the stars at the exact same moment, and so you can stand there. You can stand in Johannesburg, and you can look due south, and you can see the South Celestial Pole, and you can see slightly off center the South Celestial Pole, their favorite constellation, the Southern Star, the Southern Cross. And you can stand in Perth, and you can look due south, and they're quite a few degrees off. They're 40, 50, 60 degrees off of each other And they can both look directly due south at the same moment, and they both see the South Celestial Pole and the Southern Cross at the same time. And if you take a picture of that, a time-lapse picture, right, you see this. Right, so here's the star trails above Table Mountain in South Africa. You can see this is clearly not the North Celestial Pole because there isn't Polaris very close to the middle, right?
Sure, or you could see that mountain range is in South Africa or whatever. Yeah.
Yep. And then you can go to Australia, and there's lots of these pictures. This doesn't take. I mean, you can look up if you have any questions about whether or not these are. There's lots. It wasn't hard to find. So there's Australia, and then here's one in South America. So 3 continents, very far off of each other.
All at the same time?
All, well, they overlap. So any 2 of these would have overlapping night times. Right? South America is going to overlap Australia, but when they're overlapping,
it does work on a flat Earth with rotating stars, right? I mean, if the stars are rotating, and you're, let me pull up a flat map. Oh, hold on, I did it wrong. No, I'm not even.
I have a map.
Okay, so pull up a flat map. Like, if you're in.
There you go.
If the stars are rotating around us, for example, and you're in South Africa, and you look to your west. Well, let me see.
No, you look due south. In South Africa, you look due south.
Right. Okay. Let's say if you looked due south in Africa, and you saw, let's say you were perfectly in alignment with the star, with the Southern Celestial Pole, you would not look due south in South America. You would have to change your angle, or if
according to this map. But in reality, they look due south. That's the thing.
But what evidence do we have of that?
I showed you 3, and there's 800 million people that live in the southern hemisphere, right? I'm not gonna. Well, that's the kind of thing that if you want evidence, you can go get it yourself. That's pretty sneaking easy to get.
Well, it's a claim that at the exact same moment in time, maybe it's 3 o'clock here, maybe it's 9 o'clock there, whatever. But at the same moment on Earth, that each of those 3 countries would be due south.
It doesn't even have to be the exact same moment, because here's the critical thing. From when it's first that you can see the stars until, from dusk until dawn, the Southern Celestial Pole never moves. It's always directly right in the same spot the entire night for all places that can see it. It's always in the same place.
It has to move. Well, even if the Earth is rotating, something's moving.
The center of that rotation does not move. The center of it does not move, right? The stars move around it, and they're the ones closest draw close, tight circles, but the very center of it doesn't move. Right? So that's the thing. Like, you're just saying, what if it doesn't? And like, you're trying to not believe it. But the thing is, there's 800 million people that live in the southern hemisphere, and they can all tell you the same thing. Yeah, when I look south, I see the Southern Cross, and it's in the same place every night, pretty much, because it's not exactly in the center. And anybody can do the same thing with a camera and take that same star trail picture and see the same thing.
Sure. So what I'd be interested in is a picture from those 3 countries at the same moment in time, all looking due south.
But like I said, they don't have to be the same moment, because the key is it never moves. It's not like, well, you see it now, and now nighttime is over for you, and then click, it moves over so somebody else can see it. And now, no, nighttime is done for them. Click, it moves over to another place. That's not the thing. It's always due south for everybody all the time from dusk till dawn. So you don't have to do it simultaneously.
But if the Earth is spinning,
Yeah.
It's true relatively speaking. But it's not true if the Earth is spinning.
It's absolutely predicted by a spinning Earth. It must happen like that on a spinning Earth. If it didn't happen like that, that would be disproof.
If you had your camera pointed due south for 6 hours,
yeah,
you would catch some of it, and then you would lose it because it's rotated out of the way.
No, it doesn't rotate out of the way. On a spinning Earth, when you look due south, you will see the southern celestial pole.
Yeah,
if you're south of the equator,
you'd have to adjust. You'd have to continuously adjust your camera.
No, you would have to not adjust your camera. By definition, you must not move the camera. It once you see the south celestial pole. And I think you're not understanding how a flat Earth would work, or how a spherical Earth would work. So I have right here. So here you go. Here is.
I'm looking at your computer screen, your flat map screen.
Let me change what you're looking at here. So I see two of me. We don't want that. These dumb. I got these. My other glasses I couldn't find, so I had to get these. All right, I'm gonna have to do this. There you go. All right, here is Antarctica. Right now, somebody over here in Australia is going to look due south, right, and then whatever they see. So the south celestial pole is going to be out there, off of this, right? And so somebody up here in Australia is going to look due south, right, this way, and see the south celestial pole. Somebody in South America is going to look due south this way and see the south celestial pole.
Right now,
and same thing for South Africa here, right? They're going to look
due
south.
As you spin on the ball Earth.
Yep. And so this line coming off right here, this is the theoretical line of the south celestial pole, right? Goes straight this way, right? And it meets up with the center of rotation, which, well, it doesn't meet up with that. It's just a arbitrary point, right? And as it spins, everybody sees, but this doesn't move. They move around it, and so the camera that's looking this way is going to be looking this way, right? And then it's going to be looking this way, and then it's going to be looking this way. But it's still at the center. It's still in the same point to them, relative to them.
Yeah,
so it's a necessity on there, and people.
So can you see that 24 hours a day then?
You can't see the stars 24 hours a day because the light of the sun blocks it, right?
Right. So then, we don't know for certain that the star trails are there during the day versus moving and spinning around us.
You're right. We don't see them during the day, but from other positions of the Earth at the time, you can see them, right? So when it's daytime in South America, it's nighttime in Australia, so they can see them and confirm they didn't disappear.
Right, but by that point, they would have spun around to that side, right? You see what I'm saying?
No, they would still be directly due south.
But you just said we can't see them during the day, so how do we verify that that's true?
Because we can see them from other places at the time. When you can't see them in South Africa, you can see them in Australia. And to suggest that they might move, to suggest that they might have moved or gone away or hidden themselves somehow is quite a stretch, right? You'd have to come up with some really great explanation for what happened to them while you weren't looking at them.
well, if you okay, so you know the flat Earth model says the sun and stars and moon are moving around us, right?
Yep, I do, and
So then it's not a stretch on that model. And by the way, the geos, I would if I were not to become a flat earther anymore, I would immediately become a geocentrist, because that's what we observe. We observe everything moving around us.
well, it's a step in the right direction.
Well, I'm just saying that's an actual. If you don't like the flat Earth model, the geocentric model is the equivalent of the heliocentric model, but with the Earth in the middle and everything moving around us. And in that model, you absolutely cannot tell the difference 100%.
Except there's a lot of observations that don't work. But that's once you're there, we'll talk about that.
Well, and then again,
but
that's why I don't like going to the stars and that. I mean, it's just not.
And
just not
that's why I love going to the stars, because it.
Well,
and
but
I know, and flat earthers don't. This FE News guy has been in the chat all night here. I did a video this weekend using this flat Earth map. Well, the one that was up that you can't see it right now, right? To predict where the sun would be on the summer solstice in North America, and it would necessarily.
I saw that video. Your video, it's.
And it's not. It wasn't there. The sun wasn't there.
Why would you expect it to be there?
I would absolutely expect it to be there 21 degrees above the horizon, because that's where perspective demands that it would be. Because we can calculate perspective. And I gave a link, and you probably didn't look at it. I gave a link in the video and I'll pull it up right now quick. So here
what numbers did we use in your calculation?
We can do the math right here. Here is let's see, Minneapolis right there, 45 degrees north, and the sun would be about over Myanmar, right, at midnight on the day of the northern solstice, which was just a couple days ago, right? And there's a distance. What's that?
You're on you're showing camera, not screen.
Oh, darn it! I forgot how I did that. Yep, I'll get it. Do you see it now?
Yeah, I see it.
All right. So you see Minneapolis there, 45 north, and then there's the Tropic of Cancer, and then the sun would be directly over Myanmar at local solar midnight, so the middle of the night in Minneapolis, right? And so we can calculate the distance is pretty easy, because each degree of latitude is 69 miles. So you go from Minneapolis to the North Pole, which is right in the center. That's 45 degrees, which is 45 times 69, and then we're down to 20. So it's going to be, what's the Tropic of people? What's the Tropic of Cancer? Anyway, the latitude, right? You just take the degrees of latitude there and multiply by 69. You get 7,676 miles away. If the flat Earth map is correct, that's where the sun must be, because we know, because people live in Myanmar and they know where the sun is directly overhead on the day of the solstice, right? That's confirmed. There's nobody I've ever seen that disagrees with that. So it's 7,676 miles away. So if the sun is 3,000 miles high, but you can pick whatever number you want. But if it's 3,000 miles high, we get an elevation above the horizon, or actually above true level, of 21.35 degrees. It cannot be down. And I know you're thinking of this picture right here, or a similar one with light poles, right? Everything above the eye converges down. Right? That's how perception works. That's how perspective works. And we can calculate it. And that's what I did. I calculated where it would be. And it would be 21 degrees above the horizon. We can go to the same thing on the southern solstice 6 months from now, at the farthest south point of South America, which is as far south as you can go before you hop over to Antarctica, right? They're 54 degrees south. The sun is 17,000 miles away. That gives you an elevation of 9.53 degrees above the horizon. In the middle of the night, on the most aggressively friendly to the flat Earth number that there is. Right? That's the lowest that it could ever be anywhere on Earth, 9.53 degrees, other than Antarctica. Yet, now I've not gone to Port Williams and I've not spoken to anyone there, but I would figure that if they saw the sun in the middle of the night, they would say something about it. And certainly that doesn't match with suncalc.org or timeanddate.com, things like that people look at all the time to see when the sun rises and sets. It doesn't match any of that. And again, I've never seen anybody argue that that those numbers are wrong. The sun does set, right? It does go down. It is gone for hours before it comes up in a different place, right? And so how does that happen if the Earth is flat? There's no valid explanation. The magic lampshade doesn't do it because it actually goes to the horizon. The distance from the horizon doesn't match because it traces a very unusual shape that isn't based on distance, right? Because the North Pole would be one of the warmer places, one of the places that got the most sun on the flat Earth map.
So there is an explanation for it that I've seen, but I'm not gonna tell you. I'm gonna link you to a video to watch because I do have to go.
Okay.
And that would just take us down a whole nother rabbit hole.
Sure.
But,
all right. There's one question in chat that people have been asking that we brought up before. So I was talking about it before you got here. I was talking to a lady at work about the flat Earth, and I asked her. She said, well, the Earth isn't flat because if it was, everybody would want to go to the edge. And I know not everybody thinks there's an edge, but all the guys would want to go to the edge and pee off the edge. There'd be luxury trips to go to the edge to go pee off of it. Everybody would. And so in the chat, people all agreed, all the guys at least did, that they would want to pee off of it. So if there was an edge, would you want to go pee off it?
Sure, why not?
Thank you.
So I think the interesting thing on this video is it explains both sunsetting and north and south. God, I'm not tired. What is it called? Not circular star trails or whatever.
Sure. Is it from Eric Dubay?
No, it's not from Eric Dubay.
Okay, because his is crap. Yeah.
I posted it in the side chat if you see it.
Let me grab it. I'll copy it to the.
Yeah, I'm not an admin on your, so I can't post it on YouTube. But so yeah, check it out and let me know what you think. So thanks for having me on, and it was a good talk, good debate, whatever you want to call it.
Yeah, thanks for coming, and maybe some other time.
Okay, have a good one.
All right, thanks. Bye.
See you.
All right, people. Well, he would pee off the edge. Super. So, Decimal Z, Flat Earth Refraction, Part 2 of 3 Star Trails. So, there you go. Have a look at that if you want. I will have a look. I'll put it on my list of videos to watch to see if it's... see how good it is. So... All right, let me check. Did Ron Sheckelson did not say anything, so. All right, people. Well, that's what I have for tonight. It went a little late, but yeah, thanks. Oh, you know, I didn't announce it. I got Flurf Bingo here. Let's see. I think I missed that he said fake. If you didn't know about Flurf Bingo, I mentioned... Oh, where'd my pen go? I mentioned it in my Discord server and on another couple Discord servers. It's on my website. But next time we'll do it. Oh, here's my pen. Claims without evidence. All right. So did he say moon landing was fake? He almost went there, but I did not get a bingo. I just missed the I can't feel it. I can't feel it move. So too bad. So next time, get your sheet. There's a PDF with 33 pages on it. You pick your page, you put the number into the chat, and then I think we'll pick a winner. Whoever gets bingo first wins. So that's all I have for tonight. Thanks a lot. We'll see you next time.